let's start downloading for folks who are there in the call already.
Sure, Ravi.
I'm giving the link. Just give me a second. How many people we have now?
Good morning, sir. I'm here.
Hi. Good morning.
Good morning, sir. Yeah.
Good morning, sir.
Good morning. Folks, kindly, if you are like in the class, can you raise your this thing hand? I have six people from the class. We have around 17 people. So yeah, we need to wait. So Gauri, if you can message people to
Yes,
join.
sir, I already messaged.
Okay.
Yes, sir.
Okay. Thank you. You can drop your hands. So yeah. So meanwhile, I hope you managed to do the assignment.
Yeah, Ravi.
Yes, sir.
Yes.
Okay, we can start discussing for folks who are here, right? Like any issues you faced, let me know.
Is it with respect to the assignment, sir?
Yeah, this assignment. Let's discuss the assignment till others join.
Okay. So, sir, as per the guidelines, I
Yeah,
believe there was a data set given. There is a
yeah.
data set given, and in which we need to run a zero-shot classification on the description column, and
Hmm.
then decide what type of genre that movie is about,
Yes,
right? Depending upon the review.
exactly. And I wanted you
Uh,
to do not on the entire data set, but probably 100 or 200.
100. Yeah, so,
Yeah,
so I did 100 batches, like first 100 and then 200, and then from 200 to 300. So can I share my screen, sir? I have a small doubt as far as the
yeah.
assignment output is
Please,
concerned.
please.
I'm not sure whether I have done it properly, but I have attempted it, sir. I'll just show you. uh, yeah. So collab. Anyways, I have created a PPT also, sir, regarding that. So let me just open that up. I can run through the code. MBA, MBA to. Okay, so this is what I have done. So I ran this ILOC command to only derive description column, sir.
Hmm.
So I have assigned that to IMDb 100. So the first 100 reviews, the first 100 descriptions,
Correct.
and then I just saw the code that you had taught us in the previous lecture, and
Yes.
I ran this, and I defined the candidate labels manually.
Yeah.
So I know a bit of Linux, sir. So using Linux, I was able to get the unique labels here. So I
Uh-huh.
have just listed them, and then I
Yeah.
ran a zero shot classification on that. So
Uh-huh.
this output I got, sir. So I was not, able to comprehend or understand properly, because I do understand that this first review, which says
Yeah.
mystery. So this is the genre of the first review, and this is the genre
This
of the
is the
second.
highest ranked genre of the
Oh,
first one
right. So
with the scores.
highest rank.
You have the top ranked genres with the scores. So point 0.5 is the top rank, so it is not that strong.
Okay.
For us, a strong would mean probably above zero point 0.9 or 0.95.
Okay. Okay. So that is where I was getting confused. So here I got the number 0.45, which is almost 5%. I mean
Uh,
0.5.
uh,
And the genre assigned to that first review is mystery, right?
Correct,
As
correct,
far as
correct,
the output
correct.
is.
So yeah,
And
which
since
doesn't
yeah,
doesn't look like it's a good enough score.
okay. And I ran for 100 rows, sir. It only gave me these many. So is it fine or
No, no, these many as in, so this is your one output. Actually, you are taking, see,
Mhm.
sequence to classify would have it is just giving you sequence to classify 100 is the entire sequence, right? So you will have to loop through it. Don't run it once.
Okay?
Yeah, Ravi, I will share my screen. I have done it probably. If you can just see and let me know if it is
Okay,
fine.
so
Okay.
Kiran, you can
Sure, sir.
loop through it,
Yeah.
and there is a way to just print the top ranking here, right? Top ranking
Okay.
label. You can do that.
Sure, sir.
Yeah,
Yeah.
yeah. A good attempt. Thank you.
Sure, sure, sir.
Yeah, Ravi. So I am sharing my screen.
Yes,
Mm, we're not able to see it yet. Yeah. Now we can see it.
You can see, right?
Yeah, we can see now.
yes, we can see now.
So, Ravi, I have picked up those 100 rows, okay, as mentioned by you. So, I have taken the title as well as the description, okay, and then I have looped through the description, and these are the
Hmm,
genres which I have picked up, okay,
hmm, hmm.
few from the Excel file, and I'm just looping it, okay. So, this kind of output I'm getting for for all the movies. So from starting from first to 100, I
Yeah,
have.
let's go through some of them because
Yes,
most
yes,
of these are very famous movies. So,
right. So,
Guardians of the Galaxy, action, adventure, sci-fi sounds close. Yeah, the only problem is we are not getting high enough scores because I think one of the issues might be that the description might not be that.
no, okay. So Ravi, over here, what is like everything is adding up to 100, right? So we discussed.
Oh, okay, okay. So
But
yeah,
it is
you can
not the
probably
one
do
where.
the other one also, where
Yes,
you can allow multiple labels, so that will be higher. Can you
right,
do
right. So
that right now? If you can do maybe just for first 10
I
in the,
think I'll have to upload the
so
data
for
again.
I in data 0 to 10,
Yeah,
you
yeah.
can run that. Upload the
Let
data means as
me.
in yeah, you probably have uploaded. Okay,
Yeah, I have uploaded it, but I didn't run it today, right? I mean, this was.
okay.
Yeah.
So it will, but it will still be sitting in the collab folder, correct?
No, not exactly. So every time we execute it,
Okay,
it
then just do for 10 columns, 10 rows. That's it.
one second, one
Upload a
second.
very
Let me
small
just upload, yeah.
data set. Yeah, but yeah, good attempt. Thank you. Okay,
Ravi, I
One thing
think
maybe I am facing issue with is see so am I audible?
yeah, you are audible.
Yeah. So this data which is coming is in the form of dictionary. Okay. So this is the dictionary where I have a sequence, labels, and scores, right? So what I wanted actually additionally was to pick up only labels and score and put it in a data frame.
So yeah, you have answered your question. This is a dictionary. So just Google for how to print the dictionary values, right? So a dictionary can be accessed. You can loop through a dictionary value, right? So it
Yeah,
is
so this
already
was I was
sorted.
getting the values. Okay, so this value I was getting, but what I wanted, I actually checked on Google, a lot for checking out how can I get only labels and only scores. So this thing is not working, right? This print is not working because it's not a list. Okay, so this is something I mean, dictionary part is I'm missing. Rest everything I'm fine with it.
I'll tell you. I'll tell you. See, the dictionary printing is much easier than what you have done here in the code, right? Dictionary printing is basic. You just have to Google for how do I print each element of a dictionary, right, separately.
Yeah,
So
yeah, there is a for
or you
loop.
can
There is a
convert.
for
See, any problem in Python you have with any specific data structure.
loop.
Dictionary is a data structure, right? So just convert. Just Google for how do you convert it into a list? How do you treat it as a list, right? So that way
Ravi,
you can.
I have put it in the chat, converting dictionary into data frame.
Correct.
Yeah, thank you,
Yeah.
thank you. I will
Yeah.
just
That's not that's not something we should worry about. It's a straightforward code you'll find and you'll be able to do it. So that's not a worry.
right. Okay, so I've uploaded the data. I'll just run
Yeah.
it.
Please run that. Yeah, you can run and show it. So yeah, I think somebody else was talking about.
Someone else
Uh,
wanna show, they can show in the.
yes, Ravi, I think I've done a silly mistake. I've taken the title because the
No, no problem. Just take the description. But okay, one thing to all everyone. I think think most of the people would have joined by now. I'm hoping. Yes. So yes, you please download the data set from Cats and Dogs Kaggle's data set, because today we'll be doing machine vision, computer vision, and that data set is the one we'll be working on. And also, I shared the edition 2 link last time, right? So edition 2 is the one we'll be following, the deep learning book, right? I mean the because that's the updated TensorFlow code, the updated TensorFlow version. If any of you are following the edition 1, that's not a problem, but just keep in mind that edition 1 of the deep learning book has TensorFlow 1.6 below TensorFlow 2. Slightly the syntax might change, but the concepts remain the same, so that's not an issue, but just wanted to let you know.
So where is the data set? The cats and dogs?
Yeah, it's on the chat I have shared. If you join like slightly late, do you miss the chat or do you still see the chat? I think you'll see the chat, right?
We missed the chat.
We
Can
missed
you?
the
Okay, okay. Then we'll have to. Can you? Okay, let's. Okay, Gauri, can you mail it to everyone? I'm just pasting it again. So if you can start downloading now, even though there is a Linux, sorry, Unix, the Python command to download this in Keras, we can do that as well. But yeah, I mean, some cases it will, I mean, it will require you to upload your, there's some files for access and Kaggle ID and everything on your system, which might take time. So let's do it the old fashioned way. Let's download it manually on your system. And by the way, this data set has 25,000 images, 20,000 images, something like that. But we don't want to run it on the entire thing. When you are running it on Kaggle, we will just take 2,000 images, right? And for that, the code is there to take like 1,000 images each from the main data set and store. Okay, who else has? I think this was an assignment submission, right? So how many people have submitted? Can you tell me, Gauri?
So I have not yet submitted, Ravi. I mean, I've just done it, but it's not yet submitted. So I'll
Okay.
submit it.
Okay, so people who've not done it, can you let me know who has not done? I mean, am I correct in assuming everyone has done that? Okay, I'll ask everyone by name. That's the only. Ravi Kumar, you have done it, right?
Yes, yes.
Okay. Anand is there? Anand is not there. Anand was not there last time also.
yes, sir, he's not there.
Okay. Is he not attending?
Sir, I called, but he did not able to pick the call. I don't know why.
Okay, okay. Tyagarajan, thanks for letting us know. Yeah, okay, so anybody know about Anand? Will he be joining? Okay. Okay, so let's Anand. Okay, then. Okay, Jyoti, you have done. You'll have to upload it. Tyagarajan, any issues, Tyagarajan?
So Ravi, do you want it in PPT format, or I
No,
mean
no,
the
no.
HTML
The
file?
simple
HTML will do, right?
format. Yeah, I mean, if you're just giving a PPT, no need to give a lot of details. I would like to see maybe the output. That's it.
Okay, fine.
Okay. But if you have done the PPT, that's fine. Don't need to exclude it. Whatever you have done, whatever saves time.
I
Because
have actually not done the PPT,
then
so
fine. Don't upload. No worries. Because today's assignment will be a big one. I'll be giving you a machine vision assignment for again on a Kaggle data set. This is something I would like you to like also do. Right. So that's the main assignment. So quickly finish this one, the second one, who has not done it. Okay, Tyagarajan, any issues in the assignment?
No issues, sir, Ravi. Yeah, I not started.
Okay, last time also you had not done the assignment. So are you not getting time for doing assignments actually? Or last time you have submitted right after the extension or?
Yeah, not yet submitted yet, even the assignment one itself, Ravi.
Okay, any issues? You're not getting time or?
I'm not getting time in the weekdays on
Okay,
Sundays.
let's find time actually because I mean
Yeah, I have to do by
I mean
tomorrow.
unless you practice just listening to the lecture will help, but it will not help. It will not make you a practitioner.
Yeah. So tomorrow I will upload both assignment one and two.
Okay, fine. So Gauri, he will upload tomorrow. Please allow him to upload.
Okay, sir.
Okay, Aruna. And let's finish this quickly. I mean, we have the main part of NLP, machine vision to cover today. We'll start in around 10 minutes probably. And folks who are late, kindly call them so that they can also quickly join. Yeah, so Aruna is there in the class. Even she was, no, yes, she was not there last time also. Any
So
ideas?
she had some issues to log in to the mail. So she asked me for the link of the meeting I've shared. So she might join
Okay,
in
okay.
some
So
time.
she'll be joining. Okay, please remind me to check when she's there. Okay, so Ashish, Ashish, you are auditing the course, right? So is Ashish there? Okay, Hitesh.
No, sir, is not in the class.
Okay, Hitesh is not in the class. Hitesh was also not there in the class last time as well. Okay.
He
Any issues you know?
is suffering from some health issue.
Oh, okay, okay. Kiran, you have done.
Sir, just
Yeah, yeah.
yeah, I mean, can I copy Jyoti's code and then do it in loop,
Yeah, so
and then
see what's the see copying is okay as far as you
uh
understand, but just looping through the code in I mean creating a loop and then running your code,
mhm,
you can do it yourself also. Just again copy, see Google on how they are look. So this
okay.
zero shot model which I have given you, right?
Mhm,
If you
mhm.
Google for it, the exact code to print the dictionary also will be available, right?
Oh,
So
okay,
so
okay.
just I'm surprised people have not Googled.
You know,
Uh,
I did try, sir. I did try, and since I'm not from the coding background, I have
Yeah,
spent
no,
almost 3 days
see,
on this.
it's not a question of coding background. Google
Yeah,
has made the playing field even for all of us, right? So it's I mean, all you have to do is Google for it and see the code in the top two results, and it will show you Stack Overflow mostly on how do you do it. In fact, the link which I had shared, the one which has given the Python code, the Facebook BART large MNLI, right? That
okay.
one also, if somebody has somebody tried that model rather than the default model, the Facebook BART model?
That I have not
We
tried.
have tried that model only, right? Facebook
Okay,
Bart
okay,
Large. Yeah, we have
okay,
tried
okay,
that model only.
okay, okay. Just so you just need to try the multiple options one in
Sure,
the
sir.
same.
So after the class today, I'll probably do more research and I'll resubmit it, sir.
Yeah, yeah. So it's like so if you see the today's assignment which I'll be giving
Hmm.
is from scratch implementation of machine vision code, right? So
Okay.
don't say that you don't have coding background. The Keras has make life very easy, right? So if Keras was not there, you would be doing tensors, raw tensors, coding and other things, right? Which will be very
Yeah.
difficult. So
Hmm.
Keras is like it's like an ABCD of deep learning, right? It's like made it as easy as writing ABCD, right? So it's
Uh-huh.
pretty easy. Just learn how to Google. That's it.
Sure.
Nothing else.
Sure, sir.
Yeah.
Sure, sir. Thank you.
Ravi, actually, one thing.
Uh,
I tried on the Jupyter notebook, okay, and
yes. Yes.
when I tried with the Facebook, right,
Hmm.
Facebook MLI, it throwed error actually. So
What
I
is the
left
error?
it. No, it was not able to compatible issue or something. I left it to pipeline to select actually, choose it. I got a robot model. I chose the
No, that's fine. That's fine. Pipeline default, it will pick something
yeah,
which will be
robot.
good enough.
Yeah,
The Facebook Bartlett MNRI is sometimes heavy model. It's like 1.5 GB or GB. Also,
Could be that could be the reason. So the
that reason.
robota only it picked up, and just wanted to let you know that. Yeah.
Sure, sure. And also, people who are not using Collab, you can download it locally and give the path. It will still work. Okay.
Yeah, good. Yeah.
Ravi sir, I'll share my screen.
Yeah, yeah.
Yesterday I did this,
Uh-huh.
but I did not run complete because there were almost 1,000 lines of different journals in the. I mean
Yeah,
different
yeah. So
different.
I asked you to run
Yeah,
only 100. That's why. That's the
yeah.
reason.
So
Yeah.
I just stopped it, but I did not do for the topic. I did for positive and negative sentiments on the thing.
Okay. So if you can run it on the
Yeah, I can.
genre, yeah,
Yeah,
that
I
will
can
be
do
the
that.
that is the standard.
I can. I have to just execute this part of the code.
Yeah, yeah, sure.
I'll
Let's
do
do
it
that.
on sir. Yeah,
Yeah, yeah,
I'll do
yeah,
it.
yeah.
But one thing, sir, here it is not removing this automatically line breaks and special characters like how it does when we do cleaning up
Yes,
using.
that you can see that you can probably write a few lines of code
Yeah. But I
to
just
do.
wanted to know this will not do that, right?
No, no,
No, no.
this doesn't. This is just a classifier.
Okay.
That's it.
So it was just giving me positive, negative for each uh, this thing,
Yeah,
each
yeah.
review.
Okay, okay.
Yeah, actually, Muzamil, you need to change the data set also because whatever you are using is the reviews.
Huh.
You
What
have to
we
use
need to
the
use is
cinema
about the
plots,
movie.
movie
Yeah,
plots.
movie plot, and
Oh,
from the
The
plot you
data
need
set is
to.
present in the LMS,
okay.
So
ILBC.
Muzamil looks like you have seen the wrong assignment probably. So,
Yeah, no
but yeah,
problem.
just yeah,
I'll
no,
just
no,
change the
no
data
problem
set.
with me as well. But yeah, please
Yeah,
refer
yeah,
with assignment in data set. Yeah, okay.
yeah. I'll do that.
Okay, so yeah, so that's Muzamil is done. Muzamil I'm putting is not done. You'll have to do it. Okay, Ashish, Hitesh is not there. Kiran, Krishnakant is there or
He's not in the session,
Looks
sir.
like he's not there. Yeah.
okay? So why so many people not turning up in the class? Slightly worrying. Is it like very difficult to understand?
No, Ravi. It's nice. It's
No,
fine.
sir, it is interesting, but it's just that it'll take time. I think.
Okay. So
Ravi,
Madhukeshwar
can I
is
share?
there.
Yeah.
Yeah, yeah,
Can I share the screen?
yeah. Please share.
Yeah. What I've done, okay. I've installed the text AI.
Mm-hmm.
This one I did in Collab, but I downloaded it and opened in Notebook
Yeah,
because later the runtime will get closed
yeah.
and we lose this. So I'm reading the data, and afterwards I'm taking only the first 100 data sets,
Mm-hmm.
and I'm taking the descriptions only.
Okay.
And tags also, I'm taking genus as the tags. And
Mm-hmm.
to take the unique values, I'm taking the set of the tags
Yes, yes.
so that I get only the unique ones. But even there were the combinations of this, but I kept it as it is because anyway it was a combination of different genus,
Ah.
and created the label object and created two lists for synapses and genus. And here I just added that here.
Mm.
And this one I was printing just to see the progress because it was taking a lot of time. I was just printing the labels only. Finally, I created one more data frame with the plot and the new tag, and I added the old tag to compare whether it is properly done or not. For some it is almost 100% it has taken the same tags. Otherwise also it is almost similar because there are three
So
tags,
sorry,
two
Ravi,
tags.
you have the tags is the one you have predicted using zero shot model, correct?
No, engineer. This is the one I predicted. Tags is the
Ah.
original ones.
Original. Okay. So yeah, one thing. See, it looks good. Only thing I would say is you can probably just separate out the genre with like even the commas, and then
Only
probably
single ones.
assign.
Okay.
So ideally, you can separate
Only the
everything. Keep
first one.
no. So when you come up with a unique list of genres, right? Action, sci-fi, action, drama, thriller, right? I think
No, tags itself were like this.
no. So tags is fine,
Tags.
but if you separate it out and then you apply individually the labels. Now, if you, for
Mhm.
example, for the first one, if action and sci-fi both are above zero point 0.9, then you can say,
Mm.
okay, these two are I'm applying. Okay, action, adventure, sci-fi. Tags is the original one, right?
Yes, yes.
So for example,
See,
if you
if I
do it,
separate, what happens?
Mhm.
Yeah, if I separate engineer, I may get only action, only adventure.
No. So
Here,
that's what I'm saying. That's what I'm saying. So one approach would be when you separate, don't take only the top one. Take everything which is above a certain threshold. So for example, it
okay,
might be
okay,
above point, anything above zero point 0.9
uh,
will be your label, right? So that is one approach. What approach you have
okay,
taken,
okay.
I'm fine with it, but it might not always work because the label itself we are feeding to the model is actually having multiple words. So it might confuse the model.
Yes, yes.
Yeah, but yeah, good attempt. I like the way you have structured the problem, which is very nice. Just one change suggested. Otherwise, it's really good.
Okay. Yeah. Thank you.
So yeah, Madhukeshwar.
Okay, I'm just sharing my screen.
Mm-hmm.
So please let me know once you're able to see my screen.
Mm-hmm.
So I downloaded the required packages and also got the zero sort classification here.
Mm-hmm.
Then created the, I mean, I imported the data in
Yeah,
and then I took only 100. Okay,
yeah, yeah.
and for this getting the genre, I did the manual stuff, sir.
Okay.
What I did is I copy pasted this column C, all the
Uh-huh.
genre. Okay, then I went here and split it by the comma. Okay, and then for example like this in this.
I understood. I understood it. The cool,
Okay,
cool.
so
Yeah.
I got it into an individual
Uh-huh.
style.
This can also be done in couple of lines of Python code. You can read it as a list, then you
Okay,
can split everything using a comma. Then
okay,
whatever you got, I think just now I think Ravi's code had that making a set out of a list, right? You
yeah,
can make a set out of a list and make it a list again. It's
okay,
there like two words there in one line,
okay,
and then it will give you unique values. So that's also another way. But yeah, as long as you are getting the work done,
yes,
that's
sir.
fine.
So then I got the unique values for gender and then ran the code. Okay,
Hmm.
this is the loop for 100, and also wrote to a .txt file.
Uh-huh.
So and this file looks something like this. So this would be a one. So
Okay. Okay. First of all, I think really good. I like the flow. Uh, I think I really like the flow of work you have done here. The flow of the code also, right? So and the way output has been printed also is really good because you can see the sequence as well as the top. I mean things here. Just one. Okay. Some feedback. Maybe you can print the top three or four, except maybe not the entire. It will
okay,
make slightly easier to read, and I think you can do it easily. Your code is already there. Just maybe some small changes to your final output. But yeah, so let's go through this group of intergalactic.
sorry.
Yeah, if you can go to the text file.
Yeah.
Supposed to were to stop a fanatical warrior from taking control of the universe. Crime, sci-fi, adventure. So if you see Jyoti, in this case, he has taken the multiple labels. So his scores are very high for first two, and again slightly high for third as well. So
Yeah, Ravi, I did it as well now. So it was just multi-label which I added. So it is showing as
correct.
90 something for the first one. Yeah, 92 or something. Yeah.
Crime, sci-fi, adventure. So what's the actual one for this guy? The group of intergalactic criminals. Which movie is this, by the way?
Sci-fi. Should be sci-fi.
So it's basically three genre which is there in the Excel file. That is sci-fi, adventure, and I think so action.
Okay, so this is correct here. Then he got it correct.
Almost
If so,
correct. Yeah.
if he had given a 0.80 or a 0.90 threshold, then he might have missed action. But at least he would have got sci-fi and adventure. If he had given a 0.7470 as a threshold, you understand what a threshold is? I
Yes,
would
sir.
only take labels which are above a score of zero point 0.7.
One
Maybe
seven.
I'm just saying. You will have to decide whenever you are asked to take threshold. You have to run the output, see where the threshold is working out for you, and then take a call, right? It is not fixed that okay, always 0.90 might work for you. Okay. So let's check. If I take a threshold, what's the second one? Following clues to the origin of mankind, but soon realize this is Prometheus something, right?
So 0.8 is it's coming as adventure.
Mm-hmm. Only adventure. What is
Only
it?
adventure.
Sci-fi is not coming. Sci-fi is coming, but
Sci-fi is there, 68%.
but 0.62 is okay. Okay.
0.62.
Okay. No worries. No worries. Probably this is okay. This was but okay. The whole idea here is clear, right? You didn't have to train anything. Just the model itself, the zero shot model, helps you in identifying genres here. Okay. What's the third one? Crime, horror, and action.
Yes, sir.
It's
Crime, horror, and
Yes, sir.
action. And
It's split movie, sir. That is horror.
okay.
Thriller.
In actual, what is the actual label? An actual genre.
I think split. It could be thriller also, sir.
Horror and thriller.
Yeah, horror and thriller.
Go back
Yeah.
to that other one.
crime, crime and horror.
Yeah, crime, horror.
It is taking crime at the beginning.
Yeah,
Other thing also it
makes
took
sense.
crime.
Which makes sense. Kidnapped word is there, right? So
Yes, that's the
Yeah,
reason it
yeah.
takes crime.
yeah. Okay, let's just do one more here. What's the other one? Next one is family. Also, is family coming in the top options?
Yes, sir.
Animation, comedy, family. Let's see.
Acha.
By the way, animation is difficult to because nobody in the text will talk about an animation, right?
Yeah, animation. Yeah.
Yeah, adventure, fantasy, music.
Music.
I think even though it's not matching with the actual one, it was slightly difficult. You would probably have to take a Wikipedia description of the model where it will say this is an animated movie, right? Then it will get the correct one. But this from a small description, I think this is quite decent, the output.
Definitely.
Okay, thank you. Good job, Madhukeshwar.
Thank you.
Ravi, can I share my screen?
Yes, please. Yeah, go ahead. It's fine.
Yeah. Are you able to see the screen?
Yes. Folks who are like fine on coming on camera, it's fine. We can. We are not in a physical class, but we can switch on the cameras if you're okay.
So I've done basically what everyone has done, but in the end, I have plotted the scores as a graph. So so we can compare the original classification with the module classification.
Okay, that's nice. Can you show some examples?
So the first one here is
you can close the files section on the right. It will expand your screen.
Okay. Yeah,
but it didn't make a difference actually. But yeah, no worries. Okay.
So the first one here, the original classification is action, adventure, and sci-fi. So we see the scores here: sci-fi, adventure, and action. So it's a pretty decent classification like this.
Okay, action, drama,
Second,
sci-fi.
Yeah. So it is adventure, sci-fi, and drama. It has classified.
Okay, Amit, I don't have your name here. Were you not there in the first two classes?
I was there, but I couldn't participate properly because of a poor internet connection. I was in a remote place in Maharashtra actually.
Oh, no, so, but have you covered the topics? I mean, have you gone through all the topics covered
I've
by?
gone through the videos, yes.
Okay. So so yeah, this is good, Amit. But have you uploaded the first assignment?
First, I couldn't upload. Sir. This one I have uploaded.
Okay. First, please upload also. You can go through the simple one.
Sure.
Okay. Thank you, Amit. Yeah, if you were not like volunteer to share, I wouldn't have known because I don't have your name in my list.
Thank you, sir.
Okay, so think okay, let's quickly. Pradeep is there. Pradeep is not there. Hey, can we have the cameras on, please? Sharon is there.
Yes, sir.
Okay. Hey, Sharon, have you done the assignment?
Yeah, I've submitted it, but I didn't do that looping part, sir. I just did manually, like
Okay.
one by one.
Okay. But do you think there will be an issue in doing looping, or you are comfortable with it?
No, I tried the looping, but I think I did something wrong because it was taking only the first thing and looping it like 1,000 times. I was getting, I mean, 100 times I was getting the same for only for
Okay.
the first
Okay.
one.
Okay. You can work with somebody in the class itself who can guide you, right? Probably Jyoti or Ravi or any of the people, folks who are there. So kindly help Sharon so that she can run the loop. Yeah.
Yeah, sir. And like scores, I got very good, like 92, 94, like that, and
Okay.
then 50s like that. I can just maybe
Yeah. You want to
share.
show it? You want to share it?
Yeah. Yeah. I'll just share my screen. Um. So just this is the code. I've just opened the HTML form.
Mm-hmm.
Uh, I labels I did like manually. I think I skipped like music and drama. Um, so here like I took the first one, and then for horror it is showing 58%. But similarly I had done for these, and the first one I got 96, second one sci-fi at 92, and horror the third one is 58. So I didn't want to do it manually and waste time, so I just did for the first three.
Yeah.
But looking I can try.
Just looping. It's pretty simple.
Yeah.
Just a minute. Okay. So I'll just say work in progress. You'll have to complete it. Okay. Shrikant. Thank you, Sharon.
Yeah.
Shrikant.
Yes, I've done it, uploaded. I'll share it here actually. Yeah.
Yeah, sure, please. Right.
So can you see my screen?
Yes, I can.
So basically, like I mean, even Sharon told, like Sharon showed, I've used direct pipeline and it has taken Roberta, and I just read the IMDb and I've taken the 50 top 50 this thing descriptions.
Mm-hmm. Mm-hmm.
Then yeah, this I expanded, and then I have taken the genres, movie genres. I've added all the
Mm-hmm.
action,
Mm-hmm.
and I run a loop with a classified genre and a description.
Sure.
I could see that same thing, like the
Yeah.
split.
Small
Yeah,
feedback. You can just probably print the top 2 or 3. That's it, right? Not the entire thing. You
yeah,
can probably just use the Python dictionary.
yeah,
How
yeah,
do you print out that? That's one thing. But yeah, that's good. So Shrikant is
yeah, yeah.
done. Thank you.
Sure, sure. Thanks.
Surendra.
Sir, I didn't loop it. I did. I'll just loop it and upload it.
Okay. Okay. Sure. And so looping is left. Okay. By the way, yeah. Go ahead.
Sir, I'm so sorry to interrupt. So I just found a code to loop. This is Kiran here, sir. I have done it,
Mm.
and it is showing proper, like um, the movie name followed by the scores.
Yeah, yeah, sure. So as I said, looping is not difficult. Just you
Sure,
have
sir.
to. Yeah, yeah.
Yeah. Thank you.
Okay. So Tharuka, have you already shown? Not remembering.
No. So I've done two mistakes. One is I've taken the title and I haven't done the looping.
Okay.
I'll
Okay.
figure that out. I've submitted,
Okay.
but I'll correct it and resubmit.
Yeah. Okay. So I'll just say WAP. Tushar is.
Yeah, Ravi. So I have done the assignment, but
By
the
the way, sorry.
yeah,
I have one Tushar Nigam and another Tushar. So which
it's
Tushar?
Tushar Nigam.
Tushar Nigam. Okay. So then Tushar. Who is the other Tushar in also? Tushar, I'll just come back to you. Tushar Nigam. Tushar, other Tushar, I'm just clarifying because I have his name,
No,
but
sir. He's not there.
he was not there in the. So he first class he was there. He joined. Second and third means today also he's not there. So yeah, if you can check. Yeah, Tushar Nigam, please go ahead. Just I was
Yeah, Ravi.
just
So I have done the
checking.
assignment. The only thing I was exploring, like, I mean, the looping part is pending. So at first I was thinking if we can pass all the 100 sequences together, but now from the class I got to know that we cannot do that. So looping part I have to do.
Okay, sure. Looping part you can go ahead and do it. I'm surprised that a lot of you have not checked the probably a Google. I mean, a simple Google would have told you that it's actually looping exercise. Okay. Tushar is WIP. Amit has done. So Deepak Arora, is he here?
Sir, Deepak is down with fever, viral fever.
Okay, okay.
So last class also he was not there, and this class he has sent an email, sir, to you, to Shinu ma'am, yesterday night.
Okay, 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 okay. Cool.
So
So I hope he gets well soon, and he's also looking at probably once he gets well soon, he covers all this we have done here.
sure, sure, sir.
So I think, did I miss anyone? I have covered almost everyone in my list now. I'm assuming nobody was missed. So I'll start today's session. Let me know when you can
Sir,
see my screen.
one the
Yeah.
cats and dogs data set, right? In the Kaggle,
Hmm.
there are sample submission when I download. Is it the one actually because it only has
No, no, no. Download the images.
No, you scroll down, there is a download option. Scroll down, scroll down.
download all?
Download all.
Oh,
Yes.
okay, okay, okay. Yeah, yeah. Thanks, thanks.
Yeah. By the
It is a
way, sorry. By the way, there in Python, the console itself you can download. There is a Kaggle module in Colab. You guys, some of you might know it, right? But again, that might take time. It might require you to log into Kaggle through Colab. So that's why I'm asking you to download it manually, just to avoid time, just to save time. I hope everybody has started downloading it, right? We will come back to that. That today's most of the class will be spent on this data set only, the cats and dogs. We'll do around 4 or 5 types of machine vision exercises on that. Anyone who is not, so if somebody has already downloaded, it will be great if you can upload it on some common place. Probably take help of Karthik. Upload it on some common place, and then everybody can quickly download it. Okay. Yeah, starting today's session. Let me know when you can see my screen. Can you see the slide?
Yes, sir. Yes, sir.
Okay. Okay. Are you seeing the slideshow mode or?
Yes, sir.
Yes,
It's
sir.
in
It's in.
slideshow.
Actually,
Okay. 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 So questions from previous topics assignment has been discussed. So today's agenda is convolutional neural network. Okay, and hands-on coding, CNN application. Object detection we'll cover a simple one today and probably an advanced one in the next class, the last session, the fourth session, because fourth session is for the advanced topics in both NLP and machine vision. Semantic segmentation. Anybody who has done this before in the class, machine vision, some of maybe some basic machine vision or advanced machine vision. Anybody in the class who's already familiar?
Like we had a Azure training in that, not like advanced, like some exposed to some concepts and some
So
lab.
did
lab.
you do image classification there?
Yeah, but it was like lab exercises, like within that environment we did actually.
Using which one? Azure, which tool in Azure?
Indexer.
Okay, video indexer.
Video indexer and
Okay, yeah, video indexer is really a cool tool. It's like
yeah.
cool in the sense that you don't have to code anything. Yeah,
Yeah.
but yeah, then yeah, it's also not that much amount of fun because you don't have much control. It will give you cannot fine tune or tweak it. Let's understand how video indexer work. So by end of day today, you will know how video indexer works and how you can implement probably your own video indexer on a small scale. So CNN demystified, hands-on coding, object detection, discussion on business use cases. So I will also give an assignment today on Kaggle dataset. I have couple of data sets in mind. I'll decide by end of day today and I'll share with Karthik the assignment. Okay. So Karthik, I'll mail you. We can discuss separately and you can share it with the class. So CNN demystified. Anybody can tell me what's the full form of a CNN here?
Convolution neural network.
Yeah,
Yeah,
convolutional neural.
yeah, that's correct. Convolution neural network and CNN. Why they are famous? Can somebody tell me, or I mean, what is their speciality?
They are widely used for computer vision problems.
Hmm?
Image analytics, right?
Yeah, yeah. So yeah, CNN is a special kind of deep learning model architecture, right? Deep learning model, which is very good with image related work or image related deep learning exercises, right? So why when CNN became famous, it was around 10 years back, 2012, around that time. There is a competition called ImageNet. Okay, so ImageNet asks researchers from around the world to report their accuracy on classifying a lot of images, right? So till 2012, before 2012, people were using traditional machine learning models like SVM or maybe random forest, right, to classify those images. So they were converting those images to features, then training an SVM model, and then trying to classify. What is a classification in case of machine vision? It's so if you are given, so for example, cat and dog. If you are given a picture of a cat, you have to assign a label cat. If it's a dog, it's dog, and it is supervised learning. So you will have to train on a data set which has been labeled related to cat and dog. Okay, that's clear. So till 2012, people were using traditional models to do all this, and they were getting an accuracy of like not even maybe high 80s, right? Maybe low 80s and also 70s, high 70s. That was the kind of accuracy they were getting. Suddenly, 2012, famous scientist Jan LeCun, who is in Facebook right now. Am I audible? No issues, right, with my audio?
No issue, sir.
No issues.
So Jan LeCun, he's I think the chief AI data scientist, chief data scientist in Facebook. They probably their best data scientist, one of the leading data scientists in the world in the field of AI, right? So he and his team, they ran this convolutional neural network. By the way, convolutional, if you remember the first class, CNN is not something which has been invented in like just last decade. It has been there for some time, but we simply didn't have enough hardware to run this, right? With GPU desktops, GPU laptops in our laptops, and also things like Collab, which offer you GPU right from on the cloud, right? Things have become really easy, but like in the early 2000s or 90s, we didn't have so much computing power. So that is why even though CNN was there, we could not use it. Okay, so they use
But
CNN. Yeah, go ahead.
one thing I'd like to add here is that the first neural network was designed way back in 1975 by a Japanese computer scientist named Kunihiko Fukushima, who did the digit recognition neural network in 1975.
Mhm. So
And
that's amazing. Yeah. See. So from 1975 now to 2022, you're kind of now seeing how hot this area is, but it was first done in 1975.
And sir, also I have pasted accuracy and results of the ImageNet competition over the years in the chat. If someone is interested to take a look at it.
Yeah. So by the way, on the same note, Jan LeCun was, I mean, 2012. He like beat that competition benchmark, right, by getting an accuracy in the 90s, which was amazing. People were amazed, and then everybody started using deep learning for machine vision. Now nobody uses anything else. Everybody uses deep learning only. So, but the interesting thing is, the first time he did something using machine vision was in the late 90s. So he was the first person to use OCR. You know OCR? We will cover OCR in the fourth class.
Yes.
Optical character recognition, right? So using a machine vision model, you identify characters or text in an image. That's OCR. Okay. So he made that. He made this model, OCR model, which was used by Department of Post in USA to so right now, so you remember how in olden days, even when I think most of us have, I mean, maybe many of us have not seen postmen delivering posts, right? I mean, still they do, but it's not like that much as like probably when we were kids, right? So, but you has anybody seen how they used to sort the mails, right? So if in Bangalore there are like maybe 100 pin codes, the postman, somebody in the post office will manually look at the mails and sort it in buckets, right? Are you aware of that? How the sorting was done earlier based on
Yes.
your pin
Yes,
code.
yes, Ravi.
That's why
Yeah.
they insisted if you don't give pin code, it will take a lot of time to reach, right? They discourage
Yes.
people from missing out on pin code. Hope you all remember from your childhood, right? Even before that, probably. Yeah. So that uh, he automated that stuff, right? He said for USA Post, for post in the postal department in US, they said use this OCR model. It will automatically generate the pin code and it will sort it, right? So that saved a lot of time. People were really happy. Now that was the first business application. Okay. So that was all possible due to things like CNN. Let's study about CNN. We will first look at how does a machine look at an image, right? So in the class, can anybody, all of you can tell me what does this look like to you?
The number 4.
Yes, yes. So Ashish, you're there in my last class also, right?
Yes, sir.
Yeah. So yeah, you are aware of some of this. So probably,
Yes, sir.
yeah. So probably you can let the other folks who are attending this for the first time, because this is my favorite way of introducing CNN.
Sure, sir.
Okay. Yeah.
Partial H.
Sorry.
Partial H.
So
So
this
these are
this
just pixels of an image. So a colored
yeah,
image will have a pixel range, I think, based on the colors between 0 and 255. So I think that's
correct.
areas of
So
the image with different pixels.
yes. So this is how a machine looks at an image, right? So it will, it's for it, it's just a bunch of numbers the way we know it, right? So nobody knows how we also see an image. It's still something which is being researched on, right? But this is how a machine sees an image or a model sees an image. It's a bunch of numbers, and these numbers indicate, combination of these numbers will indicate the color and the brightness, etc. Okay. So so let's do this. Let's so if you see, the higher numbers here are on the, like, they are more greenish, right? And the lower numbers here are like very light in color, right? But it is looking like a 4 number, correct? Number 4 here, right? Now the task you have to crack here, or task you have to do here using a machine vision model, or how do you design a machine vision model? So till now, I hope everybody knows about completely connected or dense layers, right? We have done it in the last 2 classes. You remember the dense neural network deep learning model?
Yeah.
Yeah. So in that, everything is connected to the next layer, right? That's why it is called densely connected, right? So if you do this, if you solve this problem, if you want to treat this as a uh, what do you call it, the classy image classification problem, and you want to use maybe a densely connected network, how do you go about it, right? And what is is there an issue? Let's find it out. So how do we help a neural network to identify images? We will first approach it using a fully connected or dense neural network. So what we will do is we will flatten this guy. So 25, you see all these pixel values: 25, 223, 196, 249, 60, 59, 214, all these numbers, these are pixels. You flatten them, you make them in a straight line till you reach the last guy, which is 237. Okay. So I hope everybody understands flattening. Okay.
No, Ravi, can you explain
So
what
it
you mean by
makes
that?
read everything what you have here in this pattern, right? Make them in a straight line. 25 to 5, followed by 2 to 3, followed by 1 to 1, followed by 44 to 237, the fourth column. Put everything one after the other in a straight line. That is what it means by flattening.
So it's column wise, not row wise, right?
Yeah, it's column wise. If you want, you can do row wise as well. Doesn't make a difference. Okay, so so that is a traditional way, but there is an issue here. If you flatten it, do you think there will be a pattern for the machine to identify that it is a number 4? Do you think it will be easy for the machine? So that's what it is written here. Very difficult to predict, as we have lost the spatial arrangement of pixels completely. I hope you guys agree. This 4, which when it looked like this in column structure, when you flatten it, it will no longer look like 4 or 3 or 2 anything, right? It will just look like a bunch of numbers. So it will be very, very difficult. Just a second. So it will be very, very difficult to identify it as a 4. So how do you solve this problem? Any ideas?
One question, what does the blue represent? The color, the shading?
Which blue?
The numbers are colored in a certain shade of blue, right? Some are blank.
Pixel values.
Oh no, no. So those are pixel values. So if the
Pixel
numbers
values.
are higher on the higher
Higher,
side, like
dark,
249, 223, that means it will have like this the higher
dark.
green color, right? Deeper,
Oh,
deeper
okay.
color. And if it is a low value, it will have a lighter color.
Okay.
So the lines which represent a 4 are deeper, but the empty space is lighter. That's why it looks like a 4.
And how come it has 4 columns?
Because it is the way they have designed this 4 is they have put it in 4 columns, a set of numbers, right? So to us, it will look like a 4, right? It is. So let me use the pen here. See, for us humans, a 4 is like this, right? But for a machine to understand it's a 4, you need to draw this pixel wise value. So they have taken this matrix. You understand what is a matrix? A container for numbers, right?
Yes, yes, yes.
So they have taken this, whatever, what's the size of this row? Maybe 30 or 20, right? Yeah, 17. Okay, whatever. So a 17 into 4 matrix, and then they have tried to represent this 4. Okay. This 4 is, if a machine reads this, it will see this, right? Bunch of pixel values in a 17 by 4 column. Okay. Hope you understood.
Yes, yes.
Any other questions? Any other question? Okay. Now let's solve this problem. But I hope everybody has an understanding of what the problem is, right? You're trying to identify how to, or you're trying to identify the best possible way you can convert this into a bunch of features, right? Or make it easy for a machine learning model, deep learning model, to identify this is a 4, right? And we have seen that just flattening it doesn't work, because then the all this arrangement, right, like this was the top portion of 4, this is like the line, the last line of 4, right? All this is lost. Okay, so what we can do here is, let's do this. Multiply initial pixel values with weight, but sending to a dense layer still does not work. Okay, so if you multiply it with a weight, what does happen? What does it result in? I take a random weight called 3, value known as 3, or like take it as 3, multiply everything, 25 becomes 75, 223 becomes 669 and all. Do you think does it make a difference if you multiply this by a weight?
No, we are making more lighter ones towards the darker actually. Like,
Yes. So that's one thing which is happening. And the darker ones are becoming more dark. Even the lighter ones are becoming dark. So the 4 still looks like a 4, but only when it is in such a position, right? If you flatten it again, there is a problem. Nobody, I mean, the machine will have a difficult time in telling it was a 4 or not. Okay. So the whole problem we are trying to crack here is, how do we make it easy for the machine to understand, right? That's where the CNN comes in. That's where we are progressing. We are trying to see how does a CNN work by taking this example.
So in this, the right image where after multiplying weights we get the new numbers. So Ravi, I mean, what are they representing now? Are they still representing pixels? Because I think pixel.
Yeah. Every number you see here is a pixel. You are
But can a
manipulating
pixel
pixel
be more
values.
than 255?
Sorry.
Can a pixel be more than 255? Because range can be. I mean, it's should be.
So this is an indicative example. The 255 value is for the color range, right? So this is an indicative example. This might be, assume this is not color, but maybe it's a brightness. Maybe it's brightness. Okay, so it's indicating brightness, and it's in on a scale which can take maybe up to 1000. So that's the assumption here. Okay. So that's something which is, I mean, so if you take that assumption, now we are changing the pixel values, but still we are not. If we flatten it, see, ultimately for classifying, you will have to flatten it, right? Because a dense layer for classification of IMDb values, or the newswire articles we did, everything in the end was a dense layer, right? With the number of outputs equal to number of classes. Hope you all remember.
yeah.
Okay. So here, what will be the number of classes if we are to predict a 4?
Softmax?
No, that is the type of output activation function. I'm saying what is the number of outputs we will
It
get.
will be 0 to 9 or something.
Yes. It will be 0 to 9. Is everybody clear about that? Why it will be 0 to 9?
Yeah,
No.
because we're predicting the individual digits only.
Yes, correct. Hope everybody is clear, right? This is a classification problem of an image of a digit, right? So obviously the all possible outputs will be 0 to 9, because there are 10 digits which you can individually predict, right? Not more than that. Hope that makes sense.
So, sir, this number 132 will get
Hmm.
separated into 1, 3, and 2. Then it will get predicted.
Yeah,
Uh,
correct.
okay.
It's a simpler way of doing it, rather than training it on 0 to 999, right? Which will like have,
Yes.
it'll increase the number of labels you have. You will have to create a very complex model with lot of layers, because you remember in the newswire article the number of output was very high, 46. So we had to increase the number of nodes in the layer, right? So imagine if you have 999 or 1000 outputs, how many nodes you will have to start with? 2000 nodes. How much time will it take to train the model? Very high. So we don't do it. We approach problems in a simple manner, break it up into digits, and then predict only 10 digits, and then that will help us in predicting the numbers. Okay, so
So
till
sir,
now,
the
yeah,
so
go ahead.
sir, the activation will be soft max, and the number will be 10, right?
Yes. Optimization will
Okay.
be activation will be softmax for sure, right?
And number
Because
will be
that's
10.
that's what helps in identifying. That is what divides the probability into numbers which add up to 1, right? And which is the
Right.
highest number is tells you the number. I mean the class.
Okay.
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 Everybody is clear till here. Anybody who's like really confused, what are we trying to do? Okay, let's move.
Sir, what is the advantage of flattening it then? So
Which flat?
earlier we were trying to flatten
No,
the
because yeah, flattening. See, right? Flattening. You have to do flattening to predict, right? Unless you flatten it, the classification, the last layer of any classification model, right? It has to be flattened. It has to be completely connected. Only then it will predict output, right? You cannot read part of the output and only then predict, right? That is not how a classification model works. It is completely connected. It is dense. So if we start from the layer one, the first layer itself, if we make it completely connected like this, it is not helping us. It is making the job very difficult, right? So we'll have to do something special here, which will delay this flattening till maybe a later layer or a last layer. Before that, we have to do something special to read this pattern in a way, right, that we understand, okay, this is a 4. And then at the end, when we have just the minimal amount of patterns from this whole numbers, we will then feed it to last layer, which is completely flattened. Okay, so we will flatten this before sorry, we will read this in some special way, which I'll be talking about now using a CNN, and then flatten the output of the final CNN so that then it will become like a small set of numbers. And when you flatten it, it will be good enough for a model to identify it's a 4. So flattening is required, but we are trying to delay the flattening by first reading it in a special way, the features. Hope that answers.
Sir, sorry, sir, not exactly. So what I was trying to ask, like, why cannot we try to identify without a flattening? Like, why it is necessary to go ahead and do the flattening?
So the reason for that is if you have the last layer, right? So if this was my second last layer, okay, the last layer is this one where you have 0, 1, 2, 3, 4, right? 0 to 9 output, right? So this one has to be, everything has to be connected to each output, okay?
Okay.
Like this, completely connected. Otherwise, it won't work. You cannot just miss out on connecting one layer here with maybe 0 and 1 and assume that 0 and 1 will function, right? The prediction layer has to be completely connected. But the problem here is if you feed this number 4, right, to this prediction layer directly by flattening it, the only way to feed something to a completely connected layer is to flatten it in a sequence. Okay, if you do that, your output will be very poor quality because there is no pattern being identified here. You are just flattening a bunch of numbers. So before doing this, you will have to extract some patterns from here. So rather than this whole big set of numbers, you will be left with small set of numbers. You will extract patterns like this, okay, and then in the end, these small set of numbers can be flattened and fed to this last layer, and then you can generate, right? So this pattern extraction is what is helping your model to become more accurate, what is helping it to reach the 92% accuracy versus 68-70% accuracy with maybe a traditional sequential approach. Hope that makes sense.
Yes, sir.
Any other questions?
So, sir, what we basically doing is we are passing this data, and in this middle layers, we are identifying a pattern, and the output layers it basically flattens out and gives the limited number of pixels, the identified sequences, right?
Yes. So before flattening, we want to limit the number of pixels we need to flatten by using something special like CNN. Okay. So CNN will help you extract only those pixels from here which are important to identify that it is a 4 versus a 3 versus a 2, rather than feeding the entire thing.
And the output will be a flattened.
The output, yeah. So the last layer will be a flattened layer, last 1 or 2 layers, where you can feed this reduced number of pixels as a flat line, and it will give you this output. Okay. Great questions, by the way. So the other way of doing that, identifying this pattern is take 2 pixels at a time, take a 1 and 0.3. Okay. But if you do this, the problem here is you have this, I mean, and by the way, how do you take 1 and 0.3? You do a sum product. You multiply 1 with 86 and 4 with 0.3 and add it up. So you get 87.2. Okay. Simple. And similarly, you add 252 with, okay, let me take a pointer actually. Yeah, so you take a 1 with 252, 0.3 with 3, and you get 252.9. So hope it is clear. Now you see some of the problems and challenges, even advantages. You have reduced the number of data, right? So 4 columns have been reduced to 3 now, but right part is not clear. Why is that? Right part has become lighter. Why is that, you know? Because this edge, both the edges are only covered once by this, right? But this number 4 is covered twice. Once when you do this 86 and 4, then you move right and you do 4 and 8. So this 4 and 8 get covered twice by this multiplication. So its value increases, right? Hope that is clear. So right part is getting slightly lost due to low weight value, right? Also the weight value here is low, right? What you have chosen. So because of that also this has become very light. So you are losing information. But one thing positive you see is you have reduced the amount of information you had to consume in order to predict. Okay, so that's a positive thing. So let's continue on this journey.
So, how did we reduce the number of columns here?
You did a sum product with 86 and 4. You
Okay.
left with 87.2, then you shifted right 4 and 8 with 1 and 0.3. You are left with this middle number. And then last is 8 to 160, 184 becomes 1 the number. So it becomes 3, not 4 columns.
Okay. And sir, what would be the advantage of doing this?
It would, as I said, it is reducing number of columns to 3 here.
Okay.
That is one advantage. But the disadvantage is you are losing information on the right side. The brightness is becoming less here because you have multiplied only once the edges, right? Because of the way you are shifting it.
And sir, what would we gain by reducing the number of columns?
It is reducing the data amount of data you have.
Okay.
If you are feeding to a model, you remember the feature extraction class if you have attended the
Yes,
first
sir.
class. So feature extraction is you want to feed just the right amount of information. If you feed the entire thing to a machine learning model, it will perform poorly. It will have to learn like a lot of garbage as well, which is not required for prediction. So here
Okay.
you are just trying to reduce the data to just enough data so that it can learn that it is 4 and it will do it in faster time and also less processing time because you have reduced by 10% at least the number of digits here, number of pixels here rather.
Okay. Thank you, sir.
Any other question? Okay, so let's quickly understand some of these things, right? So if you put one way to avoid this case where only once this corner is covered, right, with this weight is put a set of zeros in the end, right? This is called zero padding. Okay. So when you add an extra amount of zeros, then everything gets multiplied twice. This 86 also gets multiplied twice. This 184 gets multiplied twice, right? So size of image becomes higher, but your pattern remains the same. Okay, like this. Okay, the 4 is still looking clear, and because of zero padding, your information become higher, right? So there is a disadvantage as I was just talking about, but your pattern remains the same. The 4 pattern is still easily identified. So what's the best way to approach this? Some of you might have be already aware or might have already thought of this. Rather than using just 2 weights, maybe use different weights, 1 and 0.3 and 0 and 1, 0.1 and 5 also, right? So how does that look if you combine all these? 1 0.3 0.52. Rather than doing a 2 by 2 sum product, do maybe with all these 4, right? So 86 into 1, 4 into 0.3 plus 252 into 0.5 plus 3 into 2, you are left with 219. So here, do you see it's reducing the columns as well as the 4, the pattern 4 is also clearly visible. Do you agree? Any questions?
Yeah, Ravi, actually, I didn't get it how this multiplication is happening.
So 86 into 1 plus 4 into 0.3 plus 250 into 0.5 plus 3 into 2. That's your first 4 numbers. You get 219.2. You can confirm it in the calculator.
Okay.
Some product, you understand?
Yeah.
So you take this 4, use a pen. This is what is convolution. You are convoluting this set of weights with this number. So you are taking this 4. Sorry, I took 6, not 4. So you are taking this first 4. Okay. You are convoluting or multiplying, doing a sum product with this guy. Then you are shifting by 1. You are taking this next 4, again multiplying, getting this number. Then the last 4, again multiplying, then getting the third number.
Where do
Did you
we get
understand?
these weights from? I mean, how do we decide it is 0.5 and it is 0.3?
Yeah, that is something which Keras takes care for you. It will initialize weights appropriately, and while training the weights are finalized, as you remember.
Okay.
So this is an example where I'm showing you a sample numbers just to show you that it works. But while training, Keras will learn it will initialize them randomly, and then it will learn while training which are the best weights. Okay.
Right. Yeah.
But hope this is clear. You are reducing by multiplying 4 by 4, 4 by 4, 4 by 4 to the entire figure. You are left with this final set of numbers. It still looks like a 4, but you have now less information to process, which is very good. Hope you all agree. One column is completely reduced. Okay, so this is what is called convolution. Okay, this bunch of
Ravi,
weights.
one question. So in that formula, it says D2 to E3, right?
Mhm.
You are reading a row or a column. That's why I'm
No,
confused. Are
I
you?
have not. So when I was creating this slide, I have not given the Excel formulas. So just assume that this is multiplied by 86. This is by this by this by this. Okay. So you basically fit this weight for 2 by 2 weight on this 2 by 2 first section here and multiply each one of them. Okay, and add it up. That's a sum product. Don't get confused by reading these references. Keep it simple. Okay, keep it like these 4 by this 4. Just multiply each number and add all. Multiply each number at the same location and add all of them up. Hope that is clear. Is there a confusion in that? Let me know.
Yeah, so Ravi, this part where you're multiplying, right? So right now you're multiplying with say two rows and two column.
Mm-hmm.
So, but you can also do like if you want to further reduce it, you can take four rows, four columns. Then it just becomes one. So how does one know that? Or you can even take three rows.
Yeah, good question. Good question. So we 3 by 3 convolution layer works best. Is what people have seen from experiments, right? The moment you start taking 4 by 4 or 8 by 8, your information becomes drastically small. It is no longer enough to make a prediction. So 3 by 3 works best. This is 2 by 2 because this is just an example. This is a fake example which I'm showing you to convince you that okay, how is or to show it to you how information is reduced by doing convolution, right? So by the way, in real life, when you're doing convolution, there is just not just one weight which is running. It will be like 5 or 10 layers of weights doing this, and ultimately you will be left with very small amount of information. But this is exactly the amount of information you need. So to your question, yes, 3 by 3 works the best, which people have found, and they typically use that in production convolution systems. Okay. This is 2 by 2 for an example, but 3 by 3 works the best.
Sir, can you share that code with us, or that Excel code, or
Which Excel code?
the one that you are using to convolute those calculation?
No, this
Some
so
product.
there's some product is. I mean, can you explain to me what is how is this 219 coming in? Is that clear to you?
Yeah, that I'm clear, sir, because I have formulated an Excel here in my system,
Mhm.
wherein I have formatted the numbers, and it looks four. So I have four columns. So I just want to put that formula
So it
and
will be easier to do it in a Python code rather than using it in Excel based sheet, right? So that's something. And by the way, in an MBA course, you do not implement things usually from scratch. You would use a Keras module, which will take care of everything. I am just covering this so that you understand that how does convolution layer works, or how does
sure.
convolution, this process of multiplying a set of weights with the image pixels is called convolution, right? Keep
Okay.
that in mind. That is why it is called a convolutional neural network, because you are reducing where is my highlighter? You're reducing this much information
Hmm.
into reduced information by taking this weights. I mean, taking the multiplying this by weights and reducing it. Okay, that is what is convolution. We will see some examples on how does a convolution image looks like.
Sure.
Convoluted image looks like after you pass through several layers, and it will become much more clear.
Here in this case, we used 2 cross 2, right?
Two cross
Yeah,
two.
this is
Yeah.
2 cross 2.
So
2 cross 2.
my question is like, can we like use three? I mean, how we can decide, like we can use 3 cross 3 also
Yeah,
here,
3
right?
cross 3 works best in people have found out with experiments.
Oh, okay.
Okay.
So
I'm
will there
moving.
will yeah
Yeah, go ahead.
will Keras decide in the sense our like which is the best, or should we feed that
No,
information?
we go with 3 by 3 actually. Normally, you
Okay.
can play around with it, but a lot of experts across the world have found out that 3 by 3 is enough.
Okay.
About the weights, like it's again decided.
Weight is again as not your headache, not our headache. Keras takes care of it. Unless you are doing really advanced research stuff, you never like hardly. I have seen people who are applying deep learning in their business problems. Not many of them are worry about weights. Keras takes care of it, so
Okay.
you should not worry about it.
So, sir, that
I
means
Yeah.
the convolution, or whatever this formula that we're talking about, that Kera does it automatically in the
Yeah,
backend,
that
right?
Keras is like
Oh, okay,
automatically.
okay.
I am showing you here just so that when you write the Keras code, you have an understanding what is happening in the backend at a
Got
high
it, sir.
level.
Got it,
Yeah.
sir. Yeah. Thank you.
So hope everybody is clear. This is what is convolution. And when you use a convolution neural network in Keras, you will just write a bunch of lines, right? Adding the number of layers. But remember, behind that line, this is what is happening. You are reducing something to something else. So before we take a break, just defining CNN here. This is what is convolution layer. As I said, 101, 010, very simple weights, bunch of weights here, ones and zeros. This is a weight matrix. And it is when you are convoluting something, you are extracting features out of it. Okay. So 101, 010, 101 multiplied by with this guy 3 by 3. Again, people who are asking questions, right? This is an example of a 3 by 3 weight matrix. Okay. So the first guy here gives you a 429. So we reduced everything here to a 429, and you are left with this. You started with this. What is this? 6 by 6, right? You started with 6 by 6 and you're left with 4 by 4. So
Mm.
don't you agree? You reduce the amount of data here and you are left with only the features.
Yeah.
Yeah.
Okay.
Are these weights assigned randomly?
Yeah, they're assigned randomly by Keras. You
Okay,
don't have to worry
okay,
about it.
okay.
So we define a weight matrix which extracts certain features from the images. Okay. And the last slide before the break, I want to leave you with this. This is what happens. You have an image, original image of a car, right? And you apply the convolution filter like I did in the last slide, and you're left with this hazy blurred image. Don't you agree this is a blurred image? It's
Yes.
it's blurry, it's not clear. You agree?
Yeah.
Yeah. So what has happened? What does convolution do? It behaves like a filter extracting particular information. First, so in this case, it might be extracting edges of the car. Everything else becomes blurry, right? Another filter might extract a color, maybe a brown color of the car, while another one might just blur out everything else except from unwanted noise. So this is what is happening under the hood. When you write that code of convolution layer, each layer is extracting some information out of this car image or any image you have, right? That's the whole convolution funda. Hope makes sense. We'll take a 15-20 minutes break and we'll come back and discuss it further. Okay, any questions?
Sure, sir. Thank you, sir. No questions from my side.
Okay. Thank you. Let's
Thank you, sir. Yeah.
circle back in around 20 minutes. Yeah.
Okay, right.
Hi everyone. I see Anand is back. Hey Anand.
Hi Ravi.
Yeah, I have 6 people, I think. I just maybe wait for a minute more. 7 people. Yeah. 8, 9. Okay. Okay, I think we have 12 folks back. Let's start the class. I'm sharing my screen.
And one more thing is that I hope everyone switches on their video because we want this sessions to be interactive. So can you switch on videos? Right now only sir has switched on the video, and I really hope everyone switches on the video and make this session more interactive.
Yeah, thanks, Karthik. Yeah, I think yeah, last session I had the deep learning, last 2 sessions, I had people switching on videos. So it'll be good. Okay, so let me, while people switch on their videos, let me recap quickly what we covered before we took a break. So this is what a convolution layer looks like. Oh, by the way, are you seeing my screen? The
Yes,
slide.
sir. Yes, sir. Yes, sir.
Yeah.
So this is a 3 by 3 weight matrix, right? Which you convolute or multiply with the image, and whenever you convolute with the image and you get this number here, the output, this is called a feature extraction. So you define a weight matrix. In our case, we don't need to define. This is just an example. Keras will take care of definition or initializing, which extracts certain features from the images. So 429, 505, 686. This is our feature. Okay. And this is what example output looks like when you have an original image and you convoluted it with a weight matrix and you are left with this blurry image, right? So you might ask, why is this a blurry image is important in a machine vision, right? So the way the machine vision model works is it will keep on extracting such images, such features till in the last layer, just before your dense layer, right? Just before your dense layer, your last convolution layer, it will totally stop making sense to us humans because it will just be some very important feature. Like maybe the car, this car is probably a Ferrari, right? So this Ferrari's headlight shape, right? It will just extract that. It will not make sense to any of us, but it will be an important feature for the machine vision model. Hope that makes sense. Each of this convolution layer is extracting a feature. Can I move forward? If there are no questions, hope you get the
Uh,
intuition. Yeah.
so if I understand it right,
Uh-huh.
you take the feature out and you're left with the blur image, but what the
No.
or the
So
other way
this
around?
blurry image is the feature which you have
Oh,
extracted.
other way around.
So why is it blurry? Because you're not having the complete information of the image. You just have the feature. Okay. So that is why it is blurry. It is not having complete information which would make it look clear to us. But for the machine, it is just the right amount of feature, right?
Okay.
So machine doesn't need all this complete information to be fed to it. It will just take maybe some important feature, maybe the tire shape of the car. If it is a cat, it will take maybe the eye shape of the cat or the cat whiskers, right? Those typical features of a cat, it will automatically extract and learn. So it
Oh,
doesn't need the entire image.
how do you know what feature it has extracted
No, no.
actually?
So again, that's not our headache. It's like when the training process, it keeps on extracting those features which it thinks. So, okay, great question, by the way, right? So when this training is happening, let me draw this, right? So when this, you remember this training cycle, right? So you generate an output, there is a loss function. You take this, you feed this loss function to an optimizer, which is this square box, and the optimizer updates the weight. Okay. You remember this? This weight is, and this is the input model here. Inputs architecture, right? Input model architecture. This weight is updated. So to your question, when this model starts training, this loss function is high because you're not good at it. You're not good at extracting features, right? So this weight keeps updating, and depending on the weight values, the kind of features you're extracting becomes much better. Okay, so the model automatically starts extracting much powerful features than it had earlier while it is doing this training process. Does that answer your question? So this, to your point, right? How does it know which features to extract? It comes better. It becomes better with the training process. Does it make sense? So this whole feature
Yeah.
extraction is a game of weights, right? It's like all the weights you have, you are multiplying it with the convolution layer. They are bunch of weights, right? You agree? So while
Yeah.
training, those weights change, and you extract much better features, and you become better at predicting something.
Yes, sir. So is it covered in that book, sir? Like Charlotte book?
Yeah. The one, the second edition of the book. In fact, the first edition also is information, has this information. But yeah, that book definitely has this.
Yeah, thanks.
Okay. Any other questions before we move? Okay. So this is something called as stride and padding. Now, nothing. I mean, again, stride and padding are parameters in a Keras code, which we hardly touch except special cases. Again, to be honest with all of you, not our headache, but just to understand what is a stride and padding. Let's understand. It's very easy, not very complex. When you are convoluting this 3 by 3 matrix with this image, okay, you will get this output. Okay. Now, if you take a stride equal to 2, if what is the stride? So when you take this 3 by 3 matrix and multiply with this 3 by 3, right? The stride of 1 means you will immediately move to the next, for the next bunch of calculations, you will move to the next 3, okay? And for the next bunch of calculation, the immediate next 3, like this, right? This is a stride of 1 because there is no gap when you shift this box, shift this weight matrix. But a stride of 2 means you will, after doing this first box, you will do not from 54 to 121, but from 5175 when you take this 3. So that will just leave you with not a 3 by 3 metric, but a 2 by 2 output. It reduces the number of output further. So increasing the stride value reduces the amount of information you get. Is that clear?
Yes.
Okay.
It's like from where you're starting the next iteration, right? Like
Exactly. So are you giving a gap of one column or whatever, one cell, or are you not? Or are you giving a gap of 2? So if you give a gap of 2, you are missing out on one column here. You are starting again from here. So you'll be left with a 2 into 2 matrix. And so for example, if you want to keep the output of the same size as the input for some cases, some special cases, right? Then all you need to do is add a 0 padding at the end, at all the ends, right? Just add a bunch of zeros, extra zeros, and then multiply it by a weight matrix, right? The output will be same size as input. Okay. You understand the concept of padding? Just add a 0 in case you want the size to be same even after convoluting. even after convolution. Hope that makes sense. Any questions? Any questions?
Yeah. So why is it done basically then? So
Yeah, sure. This stride is done to, as I said, to reduce the amount of information. Imagine you have like a very big image, high resolution image, and you don't want to like reduce it by just like maybe make it a 3 by 3, but reduce it further. So you will increase the stride. You know you will not be losing that much information even if you increase the stride. So stride is for that purpose. You reduce the amount of information being fed to the model. Okay, is stride clear?
yeah, but even though if we're not striding, even if the stride is one, then also we are losing information, right?
No, but but in stride 2, you're losing much more information than stride 1. And stride 3, if it is possible, you will lose much more information. You will only be left with probably one number or something like that, right?
Right. So again,
So,
but this is decided by the backend code.
stride we never play around with, to be honest. We hardly play around with stride unless it's like very, very required. Stride always remains the same. Okay. I mean, the default value. So
And
in
is there any default, as in, can we know what is the default value, 1 or 2?
one, one. One is the default value.
Okay.
Yeah.
So just a general question, Ravi. Like, so a lot of like say convolution and the steps of stride and padding, all of these are resulting in some sort of information loss, right? I mean, that's the look by the looks of it. It looks
No, so that's a great point. I would rephrase it separately, sorry, differently. Not information loss. It is signal identification. You are losing unwanted information. You are getting just the right information for machine. That's how I would term it.
right.
Signal loss for us, because for us humans, the images are becoming blurrier, and it's like more blurry, right? Till the last layer, there is this feature in Keras which allows you to see output of each layer. You will be surprised what comes out of our model giving 98% accuracy. The last layer will not even make sense to any of us. Last few layers, right? Because they are just extracting enough information to classify correctly, nothing else. Hope that answers your question.
Yeah.
It's not losing information. It is just selecting right amount of information and rejecting others. Okay. So in that case, if you keep on increasing the stride, you might not have enough information and you are losing more information than required. Other way of understanding it. Makes
I
sense?
think we don't lose any information as such because if you see stride one, whatever, right? Like we read the information, and if you put the stride one, we don't repeat the same information, right? Because again, it starts from the next column. In the first stride, like first you would have read the three columns. So stride is one, we take from the second column. So we again reread the second and third column, right? So that is avoided basically. So information
Yes,
is never lost actually, right?
yes. It's not lost. It's not lost. Class, is there any issue in switching off the videos? I see nobody has switched on, even though there was a request. I would really like
For
to be
me, Ravi,
interactive.
it
Yeah.
hampers the quality of the because I
Yeah, it makes
because
lag.
it takes a lot of
It
bandwidth.
increases the lag, sir.
Okay. But yeah, because my experience in at least the last two classes since COVID started is that having people on the video makes sense, right? And probably if you are speaking and then if you are presenting something, then it's okay to unshare. I mean, stop your video maybe if it does not work. But as much as possible, please share your video, is I would request. Thank you. It also makes class more interactive as far as I'm concerned. Okay, so okay. Stride, I hope, is clear to everyone. Padding, padding also, I need to give you an intuition, right? So imagine padding as something where you are, you have a requirement where even though you want to uh, read the information, just enough information required for machine vision task, but you also have some size constraints, right? So for example, you might be your model architecture is such that if your size reduces too much, it won't work. Just assume In some cases it happens, some complex cases, then you would need to play around with padding. You would add some fake data like zeros at the end of the model. So it will kind of allow you to, I mean, it's a fake data. It doesn't make any difference. When you convolute or convolve with it, right? You do convolution, you will have the same size, but it has extracted features, right? So that's the intuition behind padding. Padding, as the word suggests, it is padding zeros on top or on boundary, right? Makes sense?
It's like, aren't we increasing columns, right? Again, column, extra row columns, top and bottom, one on column, I mean, one on row you're adding and a column, right?
Yeah, so you only do it, that's a great point. You only do it when you have some architecture level requirement that if your image output is not of a particular size, your architecture won't work, right? So when is that required? I can give you an example. It's slightly advanced. We probably will cover it in the fourth session, but let me just give you the example, right? If you, so you remember the section about vanishing gradient. I mentioned that if you have, if in LSTM, they pass the output signal to the next layer so that the gradient does not become very weak. The signal does not become very weak. Do you remember the LSTM definition from I think the last class? Vanishing gradient problem.
Yeah, Ravi.
Okay. So in case of machine vision model also, it is recommended that ideally it's a best practice, okay, not a standard practice. It's an advanced recommendation for if you are, when you are doing high level machine vision, you are creating a very I mean high end model which has been trained on like 100,000 images or so on and so forth, right? So you, to avoid signal becoming weak, for when you are back propagating, you are updating the weights of the model, you need to pass the output of one layer, input of one layer to the output directly so that the signal doesn't become weak, right? In that case, you need to do some paddings because your size, when you pass through one layer, it becomes weak. Okay. Sorry, it becomes smaller because of the convolution. So you need to add padding so that it becomes the same size, and then the output can take it, right? That's one application of padding. Hope I was able to explain the logic why would do a padding, even though it is increasing information, but it might be required in some cases where the architecture of the model or design of the model design demands it. Did that answer you or maybe confuse you more? Let me know,
No.
please.
I understood. Like,
Yeah.
so we are doing some, like, sometimes we might need to do that after some product, right? So get back to the get back to the original sparse matrix that we had, right? Some scenarios it might be required.
When you say sparse matrix, see, image will not be a sparse matrix. Image will be a normal matrix with pixel values, right? Yeah.
Sorry, like, I just use that. Yeah, matrix. I'm saying initial.
Yeah. So the convolution here will reduce the image, right? It will reduce the image size. It is just enough information, but some requirement in your architecture, and I will bring up one example so that I have something, right? You might require that your image be of a particular size. Then you would pad it. Just pad it. Padding doesn't harm your performance. What it does is it just adds a fake layer of pixels, which is not making any difference. It just makes the machine learning model work.
So sir, is it like, just for the sake of maintaining that data frame, so that the size, though the convolution kind of reduces the columns and it processes the only the important data, right? So padding will ensure that we maintain the data frame, the size of the data as it is, without
Exactly.
having.
Exactly. Padding does that.
Okay.
Padding does that, and as I said, stride and padding, we will not normally touch, right? It will not normally require to be touched, but
Right, sir.
in some cases, so just letting you guys know that stride and padding might be a parameter. It is a parameter in your model, but we normally don't touch. We
Right,
don't
sir.
change the values.
So
Okay.
so padding doesn't make any difference. It's just to maintain the size of the data frame, right?
Yes. Yeah, it makes a difference. It increases the
Yeah.
processing time
Right.
sometimes, right?
Yes. Yes.
this. So stride and padding. So okay, so this okay. Let's. It's a very. It's a mathematical formula. What happens when you convolute something, right? So imagine a image. Okay, an image. Okay, this is a piece of information I want to share with the whole class here. You take a pen. Okay, sorry. Yeah, an image like this pixel, right? So it has a height. Okay, height value. Just a minute. It has a height value and it has a width value. Okay, so height into width. Okay, that's the number of pixels you have here. Okay, 1 2 probably. Maybe, excuse my drawing here, but 4 by 4. So height and width is 4 by 4, right? So this guy is 32 by 32. Imagine 32 by 32 is height or width. What is this 3? Can somebody tell me what is the third dimension 3 indicate here for an image?
RGB.
Yes, yes. Anybody else who wants to define what an RGB means? Please go ahead. RGB and what's the significance of that 32 into 32 into 3? Okay, let me give you an example, right? So as I told you, right, for a machine, everything is a bunch of numbers. So even colors are numbers. Okay. So I think most of us are aware that any color is a mixture of red, green and blue, right? Those are the basic colors. Red, green and blue, RGB in short, right? So to represent a colored image, maybe there is this okay, whatever you have, maybe my image you are seeing on the screen is a colored image. Now pixel wise, every pixel in that image is a combination of three basic pixels, which is RGB. So maybe it will be, so if it is a completely red image, maybe RGB, right? So it will be 255 for R, 0 for G and 0 for B. So RGB, right? So this is a completely red pixel. Now you will have maybe a 60 here, a 180 in blue, sorry, in G, and maybe a 25 in blue. So it is mostly green, but not exactly green, right? So these three values in these are called channels, right? These determine what the color will look like in that pixel. Hope it is clear. It's a combination of RGB.
All colors are the combination of this, right? Based on the
Exactly. They are all colors are combinations of RGB. So these three values determine what your pixel will look like. So if you are seeing this blue shirt here, it's a combination where a blue pixel is the highest here. Okay, and R and G are, it's not exactly maybe perfect blue. R and G will have some values. That's why you're seeing a blue here. So my image here, what you see, okay, or probably Shrikant's image here, there, right, is a pixel, right? It has height and width of the image which you see, and there is that 3 channel. So if you generate a pixel value of our images, you will get this 3-dimensional matrix. Okay, is everyone clear? Any question? Okay, why I'm covering this is because once you start running a convolution layer, you will get this question. You will ask yourself, why is this 3-dimensional image is being represented as 3 dimensions, right? So that's the answer, because image is 3-dimensional in nature. You have a height, width, and you have the color combination, the color channels. Okay, and by the way, this was covered in the first class, but as I said, I would cover it in detail in the machine vision class. A video has 4 channels, right? There is this. So video, why it has 4 channels? Can anybody tell me a video?
There is a streaming, right? There is a multiple images forms a like video. That's
Exactly.
frames.
So
Frames.
yeah, frames. So video is nothing but, I mean, my video is what? If you take images here, all these images combined will become a video, right? So it's set of images which are a video, right? So this each time step, the frame. So the time step itself, the images, group of images which make a video become another dimension. So hope this funda is clear. Just convince yourself that it is a 3-dimensional. Okay, what if it is a black and white image? If it's like a grayscale or a black and white image, it will have just one,
All
right?
G.
All G or whatever,
All
all
G.
black or all white, right? So you'll have just one channel, not 3 channels. Okay. just to clarify. So it will be like maybe 32 into 32 into 1, not 3, just one channel. So it will be there. They call it a grayscale image, right? It's like a simple black and white image. Not many things are grayscale in real life, but they use it. For so the cat and dog images we'll see today are not grayscale. They'll be 3 channel because they are colored. Oh, by the
Sir,
way, go ahead.
sir, as you mentioned that all colors are made up of only three colors, red, blue, and green.
Ah.
So then, what is grayscale made up of?
No,
Like,
grayscale is not of this RG. No, so grayscale is just like your black and white.
yes, sir, I
Okay.
understand that is black and white, but then it does not fall under RGB. It's out
No,
of
it will.
the purview of our.
You can create a black, completely black and completely white information using RGB, but you are wasting pixels. No, why do you want to waste pixels? Three channels for showing something which can be represented as one channel.
No, sir,
Does it?
that's I get your point, sir.
Uh-huh.
So what I'm trying to ask here is that, as you said, any color that I require. So grayscale would be also be made up of RGB.
Yeah, but I'm saying you see, I can represent anything using RGB, but it doesn't make sense to represent a grayscale using RGB. You are representing something which can be represented. You are spending a lot of money for buying something which can be had in 1 rupee. So that's the whole idea.
Sir, is it like if we buy a color TV, but we prefer watching it in black and white?
Ah, that's the
So,
whole thing. So, yeah.
no, sir. Sorry, I think I am not trying. I'm not framing my question well
No,
enough,
I
sir.
get your point. You're saying that when I said everything can be represented in RGB, why am I not representing RGB in
No, sir.
grayscale in RGB as well, right?
No, sir. I am asking what is grayscale represented of then? If everything is represented by RGB, then what is grayscale represented
Yeah,
of then?
okay. Grayscale is something which has only
Yes, sir.
two values possible.
But
Okay.
how will that gray color or black or white color will be formed? If every color is formed with red, blue, and green, how will that black color? Let's say I have a complete black image. How will that black image be formed?
Okay. So, okay, your question is RGB not present in blue and green and grayscale? So
Yes, sir. Yes,
technically,
sir.
no, technically you don't have an RGB component there. You just have a pixel, maybe a minimum value and a maximum value. And that shows you only so you remember the 4 number which we showed earlier. It was dark green and light green, correct? So grayscale is just a dark grayish and maybe something which is like maybe very light, right? So it's not exactly you can replicate a grayscale image using an RGB also, but we don't do that.
So black is nothing but 000.
Yes.
So here in this example, like 3 cross 32, 32, 3 is value of RGB, right? I mean, in this example.
Yeah. 3 is a
Are you
value
just
of
saying that
RGB.
it's a three-dimensional image?
Yeah. 3 is the placeholder for the 3 values of RGB. So if your RGB values, your channel will have 3 values for each pixel, indicating what is the R, what is the G, and what is the B value. So this 3 indicates that section of the image.
This 3 will also include the brightness factor in it?
It
It
can.
can.
That's a good
That's a good
point.
point.
HSV, the something called as HSV scheme. Okay, hue saturation value. Now we are not covering that, but you can also represent your image in hue and saturation. So brightness and other things also come in there, right? So have you guys heard of OpenCV module in Python?
Yes.
Yes, yes.
Okay. So I would recommend I'll give you not as an assignment. There'll be too many assignments otherwise. Uh, look at basic OpenCV tutorial, and it'll allow you to play around with pixel. Whatever I covered today, right? The pixel values. Take a picture, look at its matrix dimension, then look at what is the pixel values, okay, and then convert it into a grayscale, right? To answer Ashish's question, convert it into a grayscale and look at compare the matrix values with the RGB values, okay, and what's the difference to convince yourself, okay. It's a very easy, I mean, simple module to install OpenCV and makes image manipulation very easy. Very powerful module. Okay, so one last thing before we jump into the actual coding.
Ravi, you didn't explain the slide, the previous slide where there were 10 filters and all.
Sorry about that. So if you apply this image, which is 32 by 32 into 3, and you apply 10 filters, you know what is these 10 filters, or what are the 10 filters I'm talking about? I'm talking about the convolution weight matrix. Each filter is, in this case, 5 by 5. Height and width is 5 by 5. And the third dimension here is 3 values. Okay, so till now we were looking at simple cases where it was like simple two-dimensional matrix with like a 0, 1, 0, 1, and so on, right? Till now. But when we have a filter, a weight matrix which is 5 into 5 into 3, what will happen? This 0, behind it there will be 3 other zeros. I mean 2 other numbers, and they might be 0, 0, 0. Okay, this one behind this, now I cannot show because this is a two-dimensional screen we have. If I was in class, I would have shown like this, right? So if this is your image and it is showing 0, 1, 0, then behind this image you have 2 copies of that same number, right? So it's in I mean it has 2 other places where you can fill it. That is why it is a 5 into 5 into 3 filter. Okay, can anybody answer me why we are taking the third dimension here as 3, right? Why we not keeping it as 1? Can anybody tell?
For color, right? We discussed.
Yes, correct, exactly. So if you take just 1, when you convolute, right? What will be the output? It won't be able to convolute, because for convolution you need to multiply everything with the same position in the image, right? So unless you have 3 things to multiply with the 3 channel images, you will not be able to do this math. It will not multiply. So it has to be same size, 5 into 5 into 3, 5 into 5 into 3, with and 10 such filters, not just one. Remember, I said one filter is not enough. 10 such filters you do, ultimately your this third dimension will become equal to the number of filters you applied, and this will reduce to 28 into 28. Now this is a simple mathematical formula which I'll show you in a couple of slides, how you can come up with the final number here, the 28 by 28. But this 10 is equal to the number of filters you apply, right? Is this slide clear? This formula I'll cover shortly on how 32 became 28. This is a formula. You input the number of layers, input the number of the amount of strides, padding, which are default values, which we don't change, and you will come up with this final number. It's a mathematical formula. It's basically reducing the information. But at a high level, is this clear? What does the filtering do?
Yep.
Yes, sir.
Okay.
So, sir, 5 into 5 is actually the stride that we're trying to do, and 3 is the RGB value that
No,
is.
five is not the stride actually. It's okay. You can say it's not stride. It's the weight matrix values. Okay.
Weight
So
matrix values.
weight matrix. So this is 5 into 5 into 3 is one weight matrix.
Okay.
So
Okay.
okay. So let me do this. Okay. You see that the first dimension here has 0, 1, 0, 1 everywhere. Can you read it? Now create 2 such copies more and you stick it with this, right? So then you will get behind this. When I say behind this number, right? So then you will get a 5 into 5 into 3. Okay. It will be okay. How can I draw maybe a 2-dimensional figure here? Let me try. Okay. Maybe if this is your first 5 into 5 metric, then just stick a similar 5 into 5 metric behind this.
Right, cube will do, yeah.
And similar 5 into 5 metric behind this. Now, don't you think that the first top layer is 5 into 5 and this is like 3, then it becomes like 5 into 5 into 3, this whole weight matrix. Now, now how will you convolve here? You will take a 5 into 5 section here, okay? and you will multiply all these three values with this first set of three values here. Okay, it will give you one value. Then again, similarly here 5 times, right? And ultimately everything will be added and you will be left with one value here. Hope I did not confuse you, but I just explained to you how this filter works in for colored images.
Yeah.
Okay, so you are reducing. So that's it. No more, don't go in any more depth. This is enough depth to have an intuition of how the convolution works. It extracts these features. Done. Okay, so I'll move to the next slide. One last thing before we jump to the code is after every convolution layer, we have something called as pooling layer. Why is it pooling layer is required? Pooling, see, just by doing convolution, you are reducing the data set size, but you are not reducing it enough. Okay, so if you just do convolution, people found that it is reducing data size and it is also extracting signal, but still the dataset size is slightly more. So they applied a very simple solution. They are doing pooling. Pooling sits between each convolution layer. Okay, between two convolution layers. So you take an image, start with the convoluted image, right? So you start with the normal image. One image is missing here. You remember the earlier Ferrari photo which I had in the last slide? Imagine this is the first. You pass it through a convolution filter, you get this image. Okay, this one, what I have with the arrow, slightly blurry. This is convoluted image. Now you don't pass it directly to convolution layer, you pass it through a max pooling layer. What does max pooling does? Take a 2 by 2 of each image and just take the max value out of this. Very easy. Out of these four, which is the max value? Is it not 792? That's the answer. Out of these four, which is the max value? 856. That's the answer. Out of these four, 913. That's the answer. Out of these four, 851. That's the answer. So after doing max pooling to the convolution, you are left with even blurry image, right? But the benefit is, what's the benefit? You are reducing the amount of data and then again you pass it through another convolution and a pooling layer. So convolution and a pooling, they come in pairs. Every time you do convolution, immediately pool, convolution, pool, convolution, pool. CP, CP, CP. Remember this. Convolution followed by pooling, convolution followed by pooling. That's I have a diagram which will make it much easier, but that's something you want to remember. Any questions on this? Max pooling. You can also do average pooling, by the way. Rather than taking 792, add all four divided by number 4. Pooling layers sit between subsequent convolution. It is done for sole purpose of reducing the size of image, as I said, nothing else. And pooling is done independently in each depth dimension. Therefore, the depth of the image remains unchanged, right? So it will still be a 5 into the third dimension will still be 3 dimensions. It will not change. Most common form of pooling is max pooling, but average pooling is also done sometimes. Again, this is something you not normally play with. It will be max pooling will be there by default. Hope it is clear.
Yeah.
Other people, any
Sir, so when you say that pooling
camera?
sits between the subsequent convolution layers, that means in the previous slide wherein you showed five, three, those three layers. So does it sit between those two layers?
Okay, can you like hold on for one slide? I have a complete structure architecture diagram. I
Oh,
can answer
sure,
that
sir.
question.
Sure,
Yeah,
sure.
so just to not jump ahead,
Okay.
it will be easier actually to understand. Yeah,
Sure,
so please
sure.
please bear with me.
No problem, sir. Yeah.
So coming back to the slide show. So pooling by max. So this is okay. Please don't get confused. This is just the formula how it became from 32 to 32 to the final image, right? So the size of and this is given in that book which I mentioned. The size of the output image can be calculated as W minus F plus 2P divided by S plus 1. Sounds very confusing, but very simple. W is input volume size. F is size of the filter. P is number of padding applied. S is the number of strides. P and S, as I said, people don't normally play with it. Let's calculate. Suppose we have an input image of size 32 into 32 into 3. Okay. We apply 10 filters of size 3 into 3 into 3. Okay. So let just to show that what is image. Oh, sorry. 10. What is image size? 32, 32 and 3. Okay. 3 I'll show like this. 3. Okay. What is the filter size? Can anybody read the statement and tell me what is the filter size, the convolution filter size, weight matrix size?
10.
333 is one filter size exactly, and there are 10 such filters, means 10 such layers. So 3 into 3, right? So you want to, and there are 10 such layers. So 10 such things, whatever I have circled, there are 10 such layers. Now with single stride and zero padding. So let's understand the values here. W is input volume size. W input volume means take the height 32. F is size of the filter. Size of the filter is again take the height 3.
3.
P is the number of padding applied. Zero padding. Okay, no padding. We're not applying any padding. So P is 0. Okay. S is number of strides. So by default, I told you, right? What is the default value of stride? 1. Okay, you don't shift it by 2. You remember? So take it as 1. Now, if you plug in these values, output depth will be equal to number of filters applied. I told you earlier. Only this height and width gets changed because of this formula. The third dimension becomes equal to number of filter you are applying. Okay, 10 filters. So it will be 10. 10 in the third dimension. It will have 10 values. Okay. Why is that? Because each filter reduces the third dimension to one value, and you are applying 10 such filters. The output depth will be equal to number of filters. Size of output volume will be 32 minus 3 plus 0. Therefore, the output volume will be 30 into 30 into 10. So after passing through 10 such convolution layers, your output will reduce to 30 into 30, and this will increase. Only the third dimension will increase. So what is the sign of a convolution layer? When you apply multiple convolution layer, your height and width will keep on decreasing, but your filter, number of filters you have, and each of this is a feature. Okay, each of this is a feature which has been extracted from the main image. It will keep on increasing till the last layer. You might have maybe 10, 20, 30, however, whatever is the size of the number of filters you applied, right? In some cases it might be 128. So you have 128 values in the third dimension, and each of these is a feature. Each of this is a feature of the image, while the height and width might be just 5 into 5, right? So you have reduced the height and width, and you have just extracted features out of the image.
So Ravi, if it filter is of the size 5 by 5 into 3, so the size will be 5, right?
Size of
5 by 5 into 3, size of the filter.
Yeah, size of the filter will be no, but in here it is 3 by 3. That image had different value, 5 into 5 into 3. That's
Yeah,
why.
I'm just asking. So if I have a filter of 5
It
by
will be 5. It will be 5. So is it not coming to 28?
no, I'll calculate that, but I was just wondering if is my
Yeah,
understanding correct?
it will be 5. Yeah, your understanding is correct. Yeah. Any other questions on this one?
So basically, the value that we get will be used as length and height, right? In the output value.
Correct.
I mean, instead of 32, it becomes 30, 30. Subsequently, it
Yeah,
becomes.
it becomes smaller. Only your third dimension is increasing, equal to the number of layers you apply. Okay.
Okay.
So that's enough maths for CNN. No more maths. We are done with the high level understanding. So let us answer I think Kiran's question earlier, right? I think Kiran, you're asking this. Putting it all together, how does the entire network look like? So here is the input. Here is your first set of convolution layers. Maybe you have applied 10 layers here in one go, and each convolution is taking some of these features. Then you are pooling all of them. Again, number of pooling layers should be equal to convolution layers, number of convolution. Only then it will work. Then this is the second set of convolution layers, followed by again equal number of pooling layers. Okay. Then, so as I said, CP, CP. Okay. Now, ultimately, you have enough features here. Now you can just flatten them and pass it to the hidden network, hidden layer here. flatten it, which is completely connected or dense, and that's it. When you go to output, and you will get the output, and your accuracy will be pretty high. So to answer your earlier question, if there was no convolution layer, maybe this whole thing was missing. You would do a standard deep learning technique. You would pass the input pixels into this hidden layer directly by flattening it, and your accuracy will be very, very low, in 60% or 70%, as they used to have. But this convolution layer in between is reducing the size what you have and only extracting the important features. And when you are flattening that and passing to this hidden layer, you are getting a very good output, and you are able to get good accuracy.
One question here. Using
Yeah.
the convolution layer, we are reducing the size, right? So why do we again need the pooling layer to reduce the size? Why can't we have more?
Pooling layer does not reduce size. It just makes the data sequential so that it can be fed to a completely connected output here. So this is dense. Dense means completely connected. So for feeding into a dense layer, you flatten this, right? So you take this whatever data you have and make it in a straight line and feed it to this completely connected layer. So this completely connected layer is needed to predict the output, because a convolution layer cannot predict the output in this format, right? It is this, you need a completely connected layer like this to predict the output from 0 to 9 or A to Z, whatever, right? So that is why you need a hidden layer at the end, where the data can be sequentially fed in from the last layer of convolution, and it can generate the output. If there was no hidden layer, there is no way you can connect output layer directly to convolution. It is very, very difficult. Nobody has done that.
No,
It's
the
not
question
possible.
was regarding pooling layer.
Hmm. So pooling, okay, okay. Why do we need the pooling layer in the end? You are asking.
No, because Ravi, I think in the diagram you showed where you took the max pooling, I think there we had a matrix, and after doing the max thing, it got reduced. So if you can go back to that slide, I think that's where I think the confusion is coming in from.
Okay,
The,
this one,
yeah,
yeah.
yeah, this one. So if
Yes.
you see, yeah, so it changed. The size got reduced here.
So the question was, if we are doing the convolution layer to reduce the size using the filter, then why do we again need the pooling layer for each convolution layer?
Oh, okay, okay, okay. Thank you for clarifying. So that's, I get your question. So the answer is, if we only have convolution layer and not a pooling layer, the size will still be substantially high and not enough reduced, right? So it will take a lot of time for model to train, even though you have reduced number of features. So to further optimize the running time and also the performance of the model, we reduce it using max pooling after every convolution. So this has been found experimentally. To people are convinced now. People did not have a pooling layer earlier, but with pooling layer, the performance and the speed of the model is much more, because you are reducing the data much more. It is required to reduce the data much more. Only convolution does not work. Okay.
Okay. So in
That's the
this
answer.
case, pooling
Yeah.
the pooling is a optional, right?
No, pooling, I would not call it optional. It is a best practice. You should have pooling layer. Only then your model performance will be good. Without pooling layer, it is optional. You can remove it, but your model will not be
Okay.
performing to its what do you call it, optimal performance. Pooling
Okay.
is required to. Without pooling, the data reduction which you are getting using convolution is not enough. Simply said, if you say it simply. Okay.
Okay.
So not adding in another convolution layer instead of pooling. That
Yeah. I mean, the pooling is much more. I mean, brute force kind of thing, right? Take 4 by 4, reduce it to 1. 4 by 4, 1 1 1. So pooling is much more faster data reduction. But the benefit is, you are not. If you just pool, you will not do. You are not using any logic, right? You are just taking max of each pixel. You will lose information without any features, right? So the other question you might ask here is, why not we just do pooling and no convolution? But you know the answer. Convolution is very good at extracting features. Pooling is just reducing those features to their bare minimum values. That is why convolution followed by pooling is the best combination, and not only convolution or not only pooling. Convolution plays one role, it extracts feature. Pooling rows plays another role, it reduces the feature further and just keeps the important part of the feature. Hope I am clear.
Yes,
Both
sir. Sir,
of them have a role to play.
coincidentally, Sir, coincidentally today morning, right?
Mm.
I kind of got into this example of convolution and pooling
Ah.
even before the class. So I was updating my Aadhaar card details, and it was asking me for a photo to be uploaded,
Mm.
and the size of my photo was around 2 MB,
Mm.
but they wanted 44 KB. So I was just checking around, few websites to reduce the image size without compromising on the pixel. So there were quite a few websites available online wherein I uploaded my picture, and it reduced the size to 44 KB by maintaining the picture quality. So maybe that is a use case example, sir, or not.
Okay, so but be careful. These sites might also be using your image as a training data for their models.
Yeah,
So, 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 so
yeah,
that
I used it in. Yeah, I am aware of it, but that is kind of a use case, sir, of all these topics that we have been discussing.
yeah, I mean, it's the your use case is more of a image processing. So OpenCV, as I said, right? OpenCV is something probably after lunch I'll take maybe because
Sure, sure.
looks like the class is very interested in image processing with, I mean, before even so convolution comes slightly later, the machine vision
Mm-hmm.
problems. Before that, image processing sits there, right? It's not exactly deep learning. OpenCV is not deep learning, to be honest, right? But OpenCV is interesting, very simple. You can identify, you can change like a colored image to a black and white, a grayscale, and so on and so forth, right? So those things you can, I'll share with you a documentation. Please educate yourself. It is very easy.
Sure, sure.
Whatever you did today on a site, it can be done in using OpenCV as well.
Okay. Maybe I should have waited for a day then.
Yeah, no worries. Yeah. So yeah, this is. I hope this is clear. The entire network of convolution layer. So right now we are now ready to kind of put all this in action, right? So now it's rest of the class will be completely coding, unless I mean till the time we finish this and then we move to semantic segmentation and object detection. So let me stop sharing screen. And so, okay, let me know who has downloaded the data, cats and dogs, and let me share the link of the code with you. So as I said, we are using the Kera's book by Francois Chole, second edition. So on GitHub, thankfully, there the whole code is given. So we will use that link. I am sharing that link right now. So till that time, please let me know anybody who's already downloaded the data.
Yeah, we have done.
Yes, sir, we have downloaded.
Awesome, awesome. Because I remember in my last year's class, people had issues in downloading. And so that's why the first thing in the morning I did today was I gave you the link so that even if it takes a couple of hours, we will be good.
So this is, I mean, it's having two set of data, right? Train and test.
Yes, yes, yes. So I'll tell you what to do. Just hold on. So we will first reduce this data set. Okay, so okay, let me just share the link and then I will. I have shared a link here. So what we are aiming at is before we take the lunch break, let's all prepare the data for running the model, right? And then we'll come back and run the models. So let's aim at that. So this is the code from the GitHub link of that book, the Francois Chole book on deep learning with Python. This is chapter 8, Intro to Deep Learning for Computer Vision. So please refer this chapter when you are revising. Okay, on this page link which I have shared with you, you see you will find this text, training a convolution from scratch on a small data set. That is where we are starting. We are ignoring the first few codes which are given there. Training, did you find that section on the page? Training a convolution on a small data set from scratch.
Yes, sir.
Just search for the word scratch, Control F, scratch, and you will find it.
Just below max pooling, right?
Below max pooling, just give me 1 second. Yeah, model no max pool summary. Yeah, below that. Yeah, I'm sharing my screen by the way, just so that it is.
There, I think is directly downloading it from Kaggle, I guess.
Yeah, but I did not do it, as I said, because it requires your Kaggle login to be. There is a file that you need to upload in your collab folder, which might take time for people. So that's what I wanted to avoid. So they are actually downloading it in Kaggle for people. Okay, anybody who has not been able to download, please let me know.
Are we going to use Google Collabs or?
Yeah. Anything which is convenient to you. Google Collab, local machine, anything.
Yeah.
Okay, so one thing we need to do is we need to okay, one issue I see is help me understand if you also face the same issue is where you need to upload this image to Google Colab, right? The entire folder in order to process it, correct?
Yeah.
Google
Yes,
Colab
sir.
can't do it. Okay,
Yes,
so
sir.
will that take some time? Then you can probably keep it running over the lunch, and when you are back, it will be ready. So, okay, here is what we plan to do before we run the model. Okay, can you see my screen?
Yes, sir.
Yeah, we can
Okay.
see your screen, sir.
Okay, so there is this section called copying images to training, validation, and test directories. Okay. So, okay, this you please ignore because you've already done this. I am sure you would have got a zip file which got downloaded, correct?
Yes.
Okay, when you unzip it, can somebody manually, verbally tell me what is the folder structure which looks like when you have after unzipping?
Yeah. Partial submission, train zip and test zip. I mean,
Partial submission.
No,
No,
I mean
sample
submission.
Sample submission. You will have a train and test folder in it, I think.
Yeah. There are. I mean,
I'll share my screen,
two
sir, if you
folders
want.
and
Yes,
Yeah,
sir.
if you
We
can
have
share.
train. We have
Sir,
train.
there are so many images of cats, sir.
Yeah.
So this
No,
is
it will be
the
dogs also.
so,
Test one and train one. Please open.
yeah. So
Train
it is
one also
getting
open.
extracted, sir. It is taking time for extraction. I think there are lot of images.
So there are 25,000 images, train and testers. So the beauty of convolution is it is able to run on smaller data sets. So we will train our model only on 2,000 images. Okay.
Okay,
This is
sir.
the cat. This is cat or dog?
Both mixed test
Dog,
data.
sir. Okay, it's a cat. Yeah,
No, cat and
cat
dog.
dogs. Yeah.
Cat dog.
Mix one.
Mixed.
Okay, so
hybrid.
25,000. Yeah, there are 25,000.
okay, but the thing is, the name itself will give you an idea if it is a cat or a dog. The label. Do you see that it is cat 11.jpg or cat 12.
No, sir. It
Yes,
is
yes.
like
No,
numbers,
this
right?
is test data. No.
Test.
This is
Okay.
test
This
data.
is
I mean,
test.
in
Okay,
train
okay.
data,
Train
you
data.
have labels.
Okay.
Thank you.
Yeah,
Thank
in
you.
train
I'll
we
share
have
the
labels.
Yeah,
Okay.
thank
Okay.
you for
Please.
pointing out.
Because
Yeah,
I'm
I was
not.
worried. I was worried. Why am I not seeing cat
I'll
and
show it.
dog? Otherwise, we will have to run a new model to
Yeah.
just prepare the data.
Can you see?
This is
Cat.
very easy. Like this is now you see a cat has a name of cat.0, cat.2.
Yeah.
So okay, folks, we just have to copy.
It's a
Okay,
dog.
yeah. So you see the name cat.4, cat.155, dog is also there, right? How many images? 25,000, huh?
25,000 in
Yes.
train.
Yes.
Okay, so can we do one thing? Can we run locally, not use Colab? I hope everybody has a Python setup on your local machine, not for deep learning, but for normal Python. Do you have it?
Yes, sir.
Python 3 would do, right?
Python 3. So, okay, let me share screen again. What I want everyone to do is this. Unzip this folder,
Okay.
take this train folder and use this create paths of your small, yeah, I mean, original directory is train, okay? Give the full path here, whatever you have, okay? I'm looking at this code. Please, anybody who is not able to find the code, please raise an alarm now so that we all can help.
We are not able to see your screen.
Okay, I'm actually sharing my screen. What are you seeing?
No, sir. We are able to
We're
see your
able to
screen.
see.
We are
We're
able to
able to
see.
see.
Okay.
Copying images to training, validation, and
This
test
one.
direct.
Are you able to see now?
Yes.
So, okay, so this is a simple code which will create your in there is it will create a new directory called cats versus dogs small. Okay, and it will create this subdirectories in it for cat and dog. Okay, and it will make a subset of train, validation, and test in it, right? So it is taking 0 to 1000 in train, then remaining 1000 to 1500, 500 images for validation, and 500 and 1000 for testing. Okay, so 1000 images for training, 1000 for testing, and 500 for validation, and 1000 for testing. It is keeping this code will take care of it, right? So can you just run this code? Start running it now. If somebody is able to do it locally, please let us know, so that how does the new structure look like before we take a break.
Do we need to add a path here? Because our path would be
Ha
different
ha
wherever
ha.
we go.
Exactly,
Or
exactly, exactly. You will need to add
where do you
whatever
need
your
to change it?
C colon blah blah pura
Oh, okay,
complete path.
over
Yeah.
there, right?
Okay, so
Only
here
on the first
it should be in the folder, no sir?
Which folder, sir?
Like train and test.
No, no, train folder you need to move. Test, don't touch test. We are creating our own test data from the train data. Okay, using this code. I
So
hope
it
you
should
understood
refer
what this
the
code is
folder.
doing. It will refer the folder. Your train folder will have a path. Just paste that path here. Anybody who
Okay.
is comfortable in sharing their screen to run this code, we will run that code together.
On Jupyter local machine, sir?
Jupyter local, any machine is
I
fine,
mean,
but Jupyter, you will have to upload. So anybody who's doing it locally can do this, and then they can share it with the class here by uploading here the smaller train data. Hope that makes sense.
Can I
Then,
share my?
yeah, please go ahead.
So where's my Jupyter notebook? Sorry. Oh, it opened here. Over here, I need to give the folder link, right? Of train.
Yeah. Yeah, and you sometimes you give an R at the beginning just so that it takes it as a raw string. But yeah, let us see if it works.
Yeah, able to create. First, it created the train. Inside that, is added that.
Here also you give the path, complete path. Thank you, thank you. I think it'll.
Here also I need to change.
No, cats. Keep this name. Just add your path wherever you have deep learning. You can add it to this one. You understood what you're doing, right?
Yeah,
You're
yeah.
creating
Over
this new
here
folder
also.
in this deep learning folder which you have. Okay. So
How it should
hope
run.
there are no other changes here. Awesome, it's done. It's as simple as that. Go there in the folder. Not here. You need to go to deep learning, one level up. Oh, by the way, there are human images as well holding a cat. If you saw that. So no, it didn't do test and there is some error which happened because it's not showing for you.
How?
Okay, can you just go back to your code? I think the path might have some issue. Cats and dogs small. Okay, then you're making a subset name, start index. No, you are not. You have not called this function. There is some code
No,
missing.
she is not calling. Yeah, there
Yeah,
are
you have
three
to
more
call the
lines.
function. You
Make
have to call the
Oh.
function. Just
make
add,
subset.
copy it from there. You need to call the function. You have not called the function.
Oh, that's
The last three lines.
Oh, okay.
So you had defined
And
the
it takes
function.
time.
Okay.
Yeah, so you're training on all the images in the training folder, like there's so many images.
No, not all the images, just 2000.
Invalid argument.
Maybe it requires.
No, I think she has given the E drive, some path is changed from C to E, I think.
I saved the file in E.
No, oh, in the E, yeah.
Is your cats versus dogs small folder created? Go back and check, please. Open. No. Yeah, that one. Please open the cats versus dogs small folder. Yeah.
It's empty.
Empty. So the error is happening. So here now let's debug this code, right? So its error is happening where the train folder is
Ravi,
created. Yeah.
I shared the structure after running the code in the chat. This has created the structure. Test validation train with cats and dogs units.
Okay.
Have you done any change to the code?
If you can pass on the code.
Okay, mine is a Mac, so the paths will be different. I have used the same code. There's no difference. I just copy pasted the same code. Maybe you have to have your.
Okay, apart from these two folks who, thank you, both of you have like almost completed it. Other people, have you done it?
So in my
Can you
system,
scroll
it is
down a
still
little bit?
extracting, sir.
I
The data is
extracted the
still
test by mistake, so I'm
Still extracting.
extracted the test
Inlet
by mistake, so I'm extracting
at
right.
JPEG.
Okay, after this is done.
Okay. After maybe deep learning, it expects maybe one more slash. In Windows, it's
That's
two
the thing.
slashes.
Or otherwise, you give an R, treat it as a raw text at the
No,
beginning.
actually, can you just rename your deep learning folder like deep_learning, something like that?
Yeah.
No.
Or give an
After
R, or maybe give an R raw string at the beginning. You say R works sometimes. R, small r.
Here, yeah. Is this correct?
I just tried. No, the other one also. Yeah. Now just see. Run that folder. Now run this. No. File exists. Oh, okay. Just delete it. Whatever is there.
Yeah, delete.
Then operating system error, because you are trying to create a file with the same name again, which was created. So that will give an issue.
No. I think it's working.
Okay, so that's fine. So
Yeah.
then we'll meet at 2 o'clock. Okay, one more thing before you take the lunch break, please upload this if you are planning to use Kaggle, you need to have access to this folder structure in Kaggle. So please upload. Start uploading before you take the lunch break. Sorry about that, because it will take some time.
Collab, right?
Collab. In people who are using Collab, people who are using locally, no need to do anything. You just need the path of this new data set. Okay.
But locally it will be slow, right? I mean the image processing and everything.
No. Only if you have GPU, then only do locally. Otherwise, go to Collab.
Yeah.
I mean, that instruction still holds. I'm just saying people who have GPU system can do it locally.
Okay.
So this might take an hour to upload if in case it's like 1,000, 2,000 images, right? So start uploading before you go the whole structure. So in Collab, you should be able to access all this. Okay. Make sense? Okay, so then let's meet in an hour.
Yeah.
Thank you.
Yes,
Bye.
So one question.
Yeah.
We need to upload the entire train folder, train and test, because it is like around 300 MB. Or should we reduce the images and then?
Only this, after you first run this code,
Uh-huh.
what you just saw on the screen, it will
Okay.
reduce your data set size to
Okay.
just 2,000 images, if I'm correct, 2,000 or 2,500, correct? So can one of you confirm, Tharuka or a few more folks who have done it, how many images you are left with in the new folder, small folder?
Yeah, let me see.
You can share screen just to show people. Uzamil, you are able to do, right?
Sir, got it. Now there's a new folder. Yes, I have to upload that folder.
Yeah.
Sir, in the new folders,
Yes.
In cat there is 1,000 and in dog there is 1,000.
Yes, and test and validation, there'll be 500. Yeah, it's 1000. It shows in the folder in the bottom. Yeah.
Yeah,
Yeah.
sorry, just
No problem. No problem. Yeah. So, okay. So hope everybody got it. Before we take a break, let me check individually. So it'll not take much time. So Ravi, you have done it, right? Ravi Kumar?
Yes, yes, I have
Okay.
done it. I have to
Anand?
upload it to Collab only. Yeah.
Yeah, please do that. Anand?
Yeah, Ravi. So I'm a little lost here. I need some help. I will check.
Sure. Let's connect. Jyoti? You are done, I think. Jyoti is done. Tyagarajan, you're able to download and upload. Folks, so I asked, feel free to drop. Yeah, folks who has already answered, feel free to drop. Yeah.
So I need to download the docs versus cats.zip, right?
Yeah, as people have already downloaded it, they can share it with you. You don't need to download afresh. In fact, people help him, please. Anand joined late, right? So a bit late. So please help him with this final folder, small folder. If you can zip it and send it to him. Yeah. Somebody can zip and upload it here, the small folder structure. It will be great. People
I
can
think Ravi
directly
Kumar
download.
had already uploaded it on Teams, right? Ravi Kumar in the morning.
No, Abhi, just now
That
we
is
have
the
created the small folder.
Okay.
Now you can upload the small folder. Zip it, Ravi, please upload it, or Tharuka,
Yes,
whoever
yeah.
has done it, please zip it and upload it. People will simply download it and upload it on Collab. Make their life easy. Yeah.
Sure.
So that everyone is on the same like place. Tyagarajan, Aruna is not there. Ashish, Hitesh is not there.
No,
Kiran
I'm
Rajan.
there. I joined back. I mean, I joined a little late, but I joined.
Hitesh. Okay, Hitesh. So yeah, you'll be able to download Hitesh.
Yeah, I was running it. I think I'm facing some error, like Tharuka initially. I got blank folders.
Let's discuss this after we come back. Probably Taruka, if you can help him, if it's the same error. Okay, and then is Kiran. Kiran is done.
Sir,
Krishan.
I'm done, but I'm uploading that in Google Collab
To
now.
do it. Krishan Kant. So you feel free to drop people who have already checked.
Sure.
Kiran. Sorry, Kiran is
Yes,
done.
sir.
Sorry, Krishan Kant.
Yeah.
No, Krishan Kant Roy. Krishan Kant Roy is not here today. Madhu Keshwar. I think you would have done.
Yes, sir. I'm done.
Muzammil, I think you're done, right?
Yes, sir.
Great job.
Extracting and I'll do it. No problem.
Yeah. Okay. So,
Sir, I
Pradeep,
pasted the folder on chat.
thank you so much. Pradeep is not there, I think, right? Sharon, you're done?
Yeah, I just pasted the folder on chat.
Okay, okay, you pasted. Thank you. Shrikant, you're done probably.
Yes, sir. Yeah.
Surendra, you're done. Taruka, you're
Yes,
done.
sir.
Tushar, the other Tushar is not there. Tushar Nigam, you're done.
Yeah, I just need to upload. I'm uploading that.
Great. You can do that. Yeah, everybody needs to upload. Please take your lunch breaks now. Amit, you're done.
Yes, sir. I'm done.
Okay, Deepak is not here. In case he is here, please let me know.
So when you say upload the cat and dog small folder, right? Completely.
Yeah. The entire thing should be accessible in Keras, in Collab, because the rest of the code will be accessing that.
Okay.
Okay. Thank you all.
So we can continue in local.
I mean, local, if you have GPU, then only continue.
Oh,
Otherwise,
okay,
it
okay.
will be very
Understood.
slow. It will be extremely
Done.
slow. It will take like till the end of next class if you run once now. So,
Sure.
if you run today the code, it will give results next Saturday, unless you have a GPU. I'm not joking. I'm serious. It's some of the code will be really slow on a CPU. Okay, so see you all at 2 o'clock, and thank you. By the way, this was I think 5 minutes late, so see you all at 2:05. Okay, just to be fair. Okay.
Hey Jyoti.
Yeah, Taruka.
Hey.
Can you share your screen?
Yes. How? Yeah. I'll have to open collab, right? Yeah, hold on.
Yeah.
Okay.
Okay. Okay, it's not yet opened. Click on this folder on the left hand side.
This one, right?
Yeah. And then okay. So over here, do a right click and you'll get an option of create new folder.
Just like this, huh?
Yeah.
New folder.
Yeah.
Okay.
Okay. And you can just name it as cats and dogs. Whatever was the name of the folder, right?
It was cats.
Cats versus dogs underscore.
Oh yeah. Dogs underscore small. Okay.
Okay. Within that, you can create another folder. You can click on that right three dots, yeah, and you can create folder and you can upload it. And
Okay. So this was called what was it called? There was test, train, and validation, no?
yeah. Actually, I uploaded zip as well. I'm not sure these images are not getting uploaded somehow.
How do you wait? Let's see. Can you just upload it here? That's what I was trying to figure out. No.
I just uploaded a zip file.
Where do you, which way? How did you upload?
You can just upload now. Over here, there's an option. The first one, yeah.
So in that case, let's see non-quick file whether it's allowed.
No, it will not allow like this. At the folder level, it will not allow.
No. The other thing is I uploaded it in Google Drive as well. I was just figuring out whether you can, because it's
Where
already
did
there.
your folder structure go?
So that's a bit. Hold on. What happened now?
There's some problem with Google Drive as well. I mean, Collab as well.
Oh.
I don't know what's happening.
Hi all.
Hi.
Yeah, Ravi, hi. Ravi, I mean, were we supposed to upload the zip folder or the folder structure we have to create inside that folder and then?
Yeah. So basically, you will have to access the files. So you will have to unzip it and upload, right? So I mean, in Google, if you upload Collab the zip folder, you can unzip it there, right?
I uploaded the zip folder actually. Somehow
Yeah.
now it is not responding only.
Okay. Can
Is
you
there a thing?
restart system or something? I mean,
No,
sorry, restart login again and.
yeah, then again I'll have to upload, right? I mean, if I restart the login.
Oh, is it? So then.
Hmm.
Ravi, you
Should,
have my screen. Is there a way you can? I have uploaded in Google Drive. Is there a way you can sync the two? The folder is in Google Drive.
Yeah. There is a way to access. So you'll have to check the code, find the code for it. It's but you will. Yes, answer is yes. You can access Google Drive code from Google Colab.
I tried
You
doing.
can do a find a path. You can right click on the folder and find a path. Anybody in the class who knows how to do this, find the path and then give it the path.
So over here.
No, in Collab only we can just right click, it will show the path.
Okay.
And does anyone know how to unzip in Collab? I mean, I have uploaded zip folder.
Find a path. Is it? Where do I get the path? I'm just.
I used a file upload, uploaded a zip file actually.
Yeah, I also uploaded a zip file. How to unzip it? Do you know how
So
to unzip
I'm
it?
sharing a link on chat. How to unzip a folder in Google Colab? Just see that.
Okay.
Zip the file and upload. Let me try that.
Yeah, it's the same problem. Somebody is uploaded from Kaggle a zip folder. Yeah, I think we had around 2.5, so people should be back by 2.5.
Hi everyone.
Hi,
Just
Dr.
wanted to
Shinu.
say hi, and one big request is that either you share your screen each time or come on video mode, because only few are participating, and coming on video mode is absolutely essential, especially since you are continuing online. Can everyone come on video, please?
Hi, Shino.
Thanks, Srinivas Taruka. Thanks, Jyoti. Rajwal, you are there, right?
Ma'am, hi ma'am, it's me
Yeah.
Karthik.
Hi Krishna, can you just share your screen once and
Sir, it got unzipped using that command.